one thing. Whatever selections you made, 5 items out of 10. This is the solution of the same problem, choose. And whatever 5 items I selected, that is also a solution of the same problem, choose. So your 5 items is one solution, my 5 items is also one solution. This is my decision, this is your decision. Now, if you know simple mathematics, class 10 mathematics, how many such combination of solutions are available? How many such solutions are available? Are you agree with that? Is it a small number? Is it a small number? No. More than 50 options are there. Now, if I increase the number, the 10 to 50 and this 5 to 20, what will be the number? You are understanding, right? That much solutions are available. Now, which one is right and which one is wrong? Which one is right and which one is wrong? Now, the question is, taking decision is not so big. Taking decision is not at all a big problem. Taking decision is not at all a big issue here. It's very easy to take a decision. Then what is difficult here? What is difficult here? Sorry? Same problem that can see high number of solutions. So solution, there is no dearth of solution, there is no non-availability of solutions. So many solutions right? That is not the problem taking decisions. The problem is taking the best decision out of the available options. Taking the best decision out of the available options. If you, let us say I am asking some question to you. Let us say you don't know the answer of the question. You simply say no. So that is also a decision. And that's also a solution. And yes is also a solution. So out of the yes and no, which one is correct? Then you listen. So getting solution, the ultimate message is here. Take home message is, taking decision is not difficult. What is difficult? Taking the best solution. In mathematics, what do you say? In computer science also, we use a technical term here, right? Optimum solution. We say optimum solutions. How to find that optimum solution out of that one, that is such a big topic of discussion. And that is where we use optimization solution. So in decision making process, did you understand what is the role of optimization algorithm? We all do optimizations. So many types of optimization algorithms are there. Do you know how many types of optimization algorithms are available? How many types of optimization algorithms are in literature it's available? In literature, how many optimum solutions are available? How many optimal solutions are available in literature? How many? If I talk about intelligent optimization algorithms, for each and every animal, you will have optimization tool. I think you might have heard about that one. Starting from the ant to elephants. Starting from the ant, in Odia is input. From the ant to ant colony algorithm, the colony algorithm, this algorithm, that all are optimization algorithms, and all of them are useful for what? Machine learning and AI. We all know that one, but this is the motivation problem. I believe you are understanding what is the role of optimization algorithm in AI and ML, how important it is. So getting solution is not at all a difficult task. Difficult task is getting the best solution, and that is where our decisions are made. Now you are to learn. Obviously, our decisions will vary because you have a decision, I have a decision. But the question is who is good and who is bad, which one is right and which one is wrong. Again, at some point of time, it's very difficult to say that exactly this is right, exactly this is wrong. So you know where we stand now? We stand between this yes and no. The exactness, the extreme point is not practically feasible. We are in between them. It is partially yes, it is partially no. If I am asking, do you feel hot here? Do you feel sweating here? What is your answer? Actually no or actually yes? You are in between. You are in between. Actually you say that it is hot or actually you say that it is cool. You are in between there. I am coming to that point. Okay. So behind every decision there is a working principle. And because there is a working principle and there are different ways to work on that principle, that's why our decisions are varying. If there is one working step and it is based, that means our solution will never change. We all will give the same solution. Because it has several steps of operation, and in each and every step of operations, you have multiple options to operate that one. That's why your decisions are new data intelligence. Intelligence. Our brain is also one kind of memory. You know how much memory we have? The whole information of the universe, whatever you have at this point of time in the internet of all things, I think multiple fold of that one we can store in our brain. That is the capability of our human brain. When such a space is there here, and it can do the adaptations also. Why you are not intelligent then? Why you are not able to take better decision then? You are getting my point? Why such abilities we have, but still we are unable to take a better decision? We don't know the outcomes. So we are not able. Outcomes cannot be known. We are not able to use that. You not properly clear. Right. Then the importance of something like that. The most intelligent person in this are till today, whoever you can think of. You got my point? The most intelligent person on this earth till today has used hardly 50 or 60 maximum 60% of the human brain resources. Whoever you can think of, the most intelligent person on this earth till today has only used 60% of maximum, or maybe 70% of the maximum human brain resources. There's demand in that we use the 100% resources of the human brain, how intelligent how better. Now you ask yourself, how much resources of your brain you are utilizing? We already know that structurally and functionally human brains are similar. Then you ask yourself that what percentage of the resources you are using? What will be the answer? What will be the answer? What will be the answer? Very small. 8, 9, 10%. If you ask me how much percentage of doing something, you know. Again, I will make an approximation there, and my approximation will be less than 5%. Then who stopped me to use my own resources? Or in the other way, did I stop you to use your own resources? I mean, anyone can stop to use your own resources. Who is stopping you to, or who is telling you, or forcing you, don't use your brain?
Hi, sir.
Who is stopping you?
No.
No. Are you understanding nothing here?
Charge. Sir, charge GPT.
Who is stopping that? No one is stopping. That means my brain, my activity is everything in mind. Who are you to question on my brain? No one has a right. That means no one has a right to tell you that how much brain you should be. Nobody is telling you to use your brain, right? That means, what is the take home message here? What is the take home message here?
I am talking.
If you are not intelligent, if you are not able to take a proper decision, If you are not coming up with the proper solution, who is responsible? But do you make yourself responsible in it? We are all human beings. Do you say that I am not? Do you say every time that I am not? I am always right. One side you don't use your brain, other side you stand your brain. Which one is proper? So the take-home message is that you are not intelligent, you are the only responsible for. Never and ever blame others. We keep on blaming others. We are human beings, right? I don't blame myself. If I am not intelligent, I know how I blame. I am not good. I am not good because my friends are bad. I am not good because my society is not bad. Good. I am not good because the environment where I am staying is proper. I am not good because I am not in a proper institute which is intelligence. Intelligence. Our brain is also one kind of memory. You know how much memory we have? The whole information of the universe, whatever you had at this point of time in the digital format of all the things, I think when people hold out that one, we can store in our brain. That is the capability of our human brain. Then, when such a space is there here, and it can do the adaptations also. Why you are not intelligent then? Why you are not able to take better decision then? You are getting my point? Why such abilities we have, but still we are unable to take a better decision?
We don't know the outcomes. So we are not able.
Outcomes cannot be known.
We are not able to use that.
Right. There is information something like that. The most intelligent person on this earth till today, whoever you can think of, you got my point? The most intelligent person on this earth till today has used hardly 50 or 60, maximum 60% of the human brain resources. Whoever you can think of, the most intelligent person on this earth till today has only used 60% of maximum, or maybe 70% of the maximum human brain resources. Just imagine that we use the 100% resources of the human brain, how intelligent we are. Now you ask yourself, how much resources of your brain you are utilizing? We already know that structurally and functionally human brains are similar. Then you ask yourself that what percentage of the resources you are using? What will be the answer? What will be the answer? What will be the answer? Very small. Maybe 9-10%. If you ask me how much percentage of student resources, you know, again I will make approximation there, and my approximation will be less than 5%. Then who stopped me to use my own resources? Or in the other way, did I stop you to use your own resources? Or is anyone that can stop to use your own resources? Who is stopping you to, or who is telling you or forcing you, don't use your brain?
Hi, sir.
Who is stopping you?
No.
Are you understanding the logic here?
Charge. Sir, charge GPT.
Who is stopping that? No one is stopping. That means my brain, my activities, everything in mind. Who are you to question on my brain? No one has a right. That means no one has a right to tell you that how much brain you should do. Nobody is stopping you to use your brain, right? That means What is the take home message here? What is the take home message? If you are not intelligent, if you are not able to take a proper decision, if you are not coming up with the proper solution, who is responsible? But do you make yourself responsible anything? We are all human beings. Do you say that I am not? Do you say anytime that I am not? I am always right. One side you don't use your brain, other side you say I am always right. Which one? Proper. So the take home message is that you are not intelligent, you are the only responsible for. Never and ever blame others. We keep on blaming others. We are human beings. I don't blame myself. If I am not intelligent, you know how I blame? I am not good. I am not good because my friends are bad. I am not good because my society is not bad, good. I am not good because the environment where I am staying is proper. I am not good because I am not in a proper institute teaching now. I am not good because I didn't read properly. And that
signal word we always listen, electrical signal, voltage signal, current signal. So everywhere signal, that word, what does it mean? Because it is a set of information or data. Why we have that signal, why we are using that signal? Because it has some information. And that information we need to utilize for some task. Some of the responsibility is there with that signal such that it will perform a task. So any kind of physical variable subject to variations represent a signal. So this is a common definition, like variations and physical variable. Okay, so these are the two keywords associated with a signal. And signals can be represented mathematically by either in one dimension, that is speech signal, which is a variable with time. Another is image. Here the image is there. Image means it has spatial variations, spatial variables. So two dimensions. One is your x-axis, another is y-axis. Then you are having a picture. So that is having two variables. Both are variables, x and y. However, which is varying with time. That means it is three variables. So first is signal, which is magnitude is varying with time. Okay. So when you are varying the time, accordingly how the magnitude or amplitude is varying, that is called signal, because it is one dimension variable. Now here it is two dimension variable. Now multiple images are there, then it is called three dimension variable, which is called video. So in this way, we, a common people, we understand the signal. So video is also a signal, but three-dimensional signal. Image is also a signal, but two-dimensional signal. But always we write that signal means, in our mind, we always assume that it is one-dimensional variable, and image means two-dimensional variable. That's why we are separating signal and image. Otherwise, image is also a signal, but with two dimensions. Now again, signal, when we describe with respect to its variation, it is continuous time and discrete time. Okay, so there are two basic types in the continuous and discrete. So these things everybody knows. Discrete time variables, continuous time variable, similarly discrete magnitude and discrete. Discretize the magnitude, discretize the continuous magnitude. So all four combinations are there. Either time is variable or amplitude is variable. So accordingly, we do, what is the process? If a continuous time signal, if we want to discretize it, what is the process? We sampling. Similarly, discretize the amplitude, we go for quantization. Okay, so these are the very important words in current scenario because we are working in digital domain. So to convert an analog signal or continuous signal to a digital signal, we have to do sampling and quantization. So these are the illustration of these two kind of signals. So it's a continuous time, continuous amplitude signal. This is a discrete time but continuous amplitude signal. But also amplitude can be also discretized. So next process is processing. Okay, so these are the basic idea about what is a signal. Now, why we need processing? Because signal is there. Why we need so much processing? Because we want the information content in the signal to be utilized properly. So, signal processing is the science and technology of analyzing, modifying and interpreting the signal. Okay, so you have to analyze the signal because what are the information present in the signal that we have to extract and we have to use it for our purpose. Otherwise, why we need processing? Definitely, we have to analyze it. So for analysis, we do some modification and then we interpret what is the output, what are the instruction coming from that signal or hidden in the signal so that we can use it for our whatever our goal. So processing means in digital domain, what do you mean by processing? Means some mathematical operations or algorithms we are, okay. So basically these are the processing that is enhance the signal means first you remove the noise. Enhance means definitely the quality of the signal to be enhanced. Quality to be enhanced means whatever the unwanted signal are there or unwanted contents are there that are to be removed and that is called noise. Noise is the unwanted part of the signal which are to be removed. So that will definitely once you remove the noise, the quality of the signal will be enhanced. Then we can go for the extraction of information through feature detection, pattern recognition. So through all this process, you can go for some information extraction. The third part is called transform the signal. The signal is transformed from this whatever the time domain signal to another domain. So that is called transform. Just like Fourier transform, we have heard of so many transforms, Laplace transform, Fourier transform, J transform. So why do we go for those transforms? Similarly, so many other transforms are there, wavelet transform. So why we go for transformation? Why we are transforming to different form? When you are transforming a signal, suppose you are doing Fourier transform. What is the changes? Because Fourier transform, about that everybody knows, I think.
They're converting time domain to
Frequency domain. So why we go do that?
because easily you can manipulate in frequency.
Why easily you think? Why you think that easily it can be done in frequency domain, not in time domain?
In case of suppose convolution, up to time domains are there. It is calculated term is very difficult. But in frequency domain, you can calculate easily.
So that is one example.
Yes.
Okay. So we do transformation because of some advantages, definitely. So what are those advantages that we have to understand first? Just like sir told that when we are transforming from time domain to frequency domain, then we can analyze the frequency content of the signal, which is what are the frequencies present in the signal, we can easily understand. But in time domain, we cannot understand what are the frequencies present. We can only understand how it is varying with time. But how it is varying with frequency, we cannot understand. That's why we have to transform it to Fourier domain and we analyze in frequency. But some other advantages are also there, that is called correlation. Correlation of the signal. We want to decorrelate as much as possible with the variable. Suppose at what time, what frequency is present, we are not able to understand in time domain. We can only understand what is the time. At that time, what is the amplitude. Similarly, in frequency domain, we can understand at what frequency, what is the amplitude. But we cannot understand at this time what frequency is present and what amplitude is present. All three combinations for that. Similarly, time frequency analysis is required and we need some other transform. That is called vector transform. Is one of the examples.
Madam, also in frequency domain,
Yes.
initial conditions are automatically taken care of.
Yes. So in frequency, so many advantages we find, that's why we go for transform. The one of the advantages for analysis, you will get some better information. Second is you are getting more decorrelation, and most of the, just like discrete cosine transform, the energy, whatever the signal energy, that is concentrated in few of the components instead of in all components. So we can do easily the compression also, and that will reduce the computation or storage capacity. Okay, so in this way, lot of other advantages are there, because nowadays we are processing the signal in the digital domain. So from digital point of view, we have to see how it can be stored efficiently, how it can be transmitted efficiently. So from every point of view, we think that the transformation-based analysis is much more efficient than the time-based analysis. So analog signal processing, it deals with continuous signal. Digital signal processing deals with definitely digitized signal. So these are the examples. So everybody knows. Now coming to the image. So image is also a signal, but it's a two-dimensional entity, and this is the digitized output of the analog image. Okay. So this is the analog image and this is the digital image. Now pixel values which represents gray levels, colors, heights, opacities. So this can be variables in the image. So image can be grayscale image, only black and white image, and also colored image, and also another image called variation with opacity. That means 4 dimensions. Okay. So image can be a completely black and white or grayscale or colored. In color, what you will find? RGB. Okay, red, green, blue. 3 axes you will find. So for x and y are the variables. Each variable you have a pixel, and that pixel has 3 intensities. Okay. When it is grayscale image, 1 intensity. When it is color image, you have 3 component of the intensity. That is called RGB. So this is your grayscale image, this is your color image, which is red, green and blue. And in grayscale, either you will find black and white or grayscale, that variation. So one value you will find for each pixel. Here you will have 3 values you will find RGB. Here you will find 4 values, red, green, blue, and another is called alpha. Alpha represents opacity. So in this way, different representation of digital image is there, and we process also accordingly as per our requirement. So similarly, because we want to extract the significant information from the image or signal, that's why we go for processing. So image processing, it focuses these two major tasks. One is how to improve the pictorial information for human interpretation. Second is process the image data for storage, transmission, representation, and autonomous machine perception. Whatever nowadays you know, image processing and computer vision are having a major role in machine perception, or everywhere we go for image based classification. So lot of applications we have. So these are the things for which image processing is required. So some argument about the processing, where image processing ends, then image analysis and computer vision start. Okay, because image processing and computer vision are not same. First we do the processing. From the processing, we get some information which is used for computer vision. Okay, so computer vision is called high level processing. So this is how image processing is divided. So this is called low level processing, this is called mid level processing, and this is called high level processing. So in low level, the pre-processing part is done. Just remove the noise, do some filtering. Okay. So what happens? The image is having lot of noise or lot of distortion, so you can remove them. So why those noise is there? That is due to instrument. Whatever the due to your image acquisition, during image acquisition, you are having the noise associated with the image. So image, whatever the associated noise can be removed by some pre-processing. That means you have to use some filters. We know so many filters are there: low pass filter, high pass filter, band pass filter. Okay. So low pass filter means it will pass the low frequency, and high pass means it will pass the high frequency. Now, looking from the image point of view, low frequency. What do you mean by low frequency?
Actually, I have some question. Actually, if there will be some optical illusion, under some circumstances, how can we separate the wavelengths? So if there will be optical illusion, actually there is no problem. Just make them separate. If there will be illusion, something is not visible, so we can say that drastically the image is different. But out of that, we would like to make them
Optical illusion, it is our totally a human vision based optical illusion. Okay. Now machine doesn't understand what is optical illusion. We are now, whatever we are using, that part is associated with how we will apply it to.
Can we apply this one to the machine that can be separated with the help of the light?
Optical illusion is only associated with our human vision. So that is not that why we will apply, because that creates a problem. Why we create that problem to the machine? We will give real data to the machine. Machine will have no optical illusion. Optical illusion is associated with our human vision. Okay. So we find different kind of illusion.
So we are mapping the brand mapping is wrong.
That's right, because in exact processing of our brain, we cannot map into the machine. So whatever input we give to the machine, accordingly, we think that accordingly that intelligence we are feeding to the machine. So that depends upon how, that is also again designed by human being. Okay, first we have to write a code, we have to write an algorithm accordingly, and we have to feed to the machine. So why we feed that optical illusion which will create a problem? Okay, you can create it, but why we create it is not required. It's an unwanted part. Okay, but it is a study that we human beings have optical illusion. Okay, and what are the optical illusions? Lot of examples are there. So that should not happen with the machine. That's why we don't give any optical illusion to the machine. So we divide the image processing into three parts: low level, slow signal processing struggles with. Manually, it is very difficult. In some cases, complex signal analysis, which is not possible manually, that's where the machine is required. Because we have to understand why machine has to be learned, because of this complexity. But in simple analysis, manual analysis is not required at all. Manual analysis can solve the problem. But when complexity increases, at that time only our machine is required. So it can automate and improve accuracy of tasks like classification, like disease diagnosis from medical signals. So I will show you some examples where you can understand that how it can be easily done. Another is adaptive to new data, useful in high dimension data, improve denoising. So these are the processing part which can be done. So just like a human, let us the human first look at all these objects and it learns that yes, this is a car, this is also a car, this is a bike, this is a bike. So it understands that these are the devices or these are the objects just by observing them continuously. Okay? So the human can understand that this is a car, this is a bike. From where? How it will understand? Because suppose it observes that it has 4 wheels, then the shape is like this. So some kind of features are there. From those features only it understands, yes, this is a car. How we human being differentiate that this is a car, this is a bike? How? First the number of wheels, then the size and shape, structure. Okay, so these are the various features. So these are called features. So human being just learns by observing them. Then you ask, what is this? Then it will immediately reply, yes, it is a car. Okay, so the car is the category. Okay. Now same thing, a machine has to learn. So how you will learn the machine? The machine you will give this data set. This is called data set. Now this data you feed to the machine and the machine will learn it. Okay? So data set is the input first to train the machine. We tell not training data set. So this is called training data set. We first give to the machine. Then this is what we call the training data set. First feed to the machine to provide the training to the machine. So after giving the training, what we do? We devise the algorithms and execute the program on this data. So how you give the training? You first give them training by writing some algorithm. So this has to be added. Okay, so this is the input data set, this is the machine, then this is the algorithm you design. Now this is fed to the machine by giving this data set and then it will understand the task. So what are the tasks? It will understand it will identify the required rules first, then it will extract the patterns, what are the patterns present in those objects, that is features. Okay? So how it will extract all these features? It is the task. So extract the required patterns, then identify what are the relations among those patterns. Okay? So this is the rules, patterns, the relations. These 3 things it will learn. Okay. So this is the data set you are feeding to the machine, writing the algorithm through which it will understand what are the rules, what are the patterns and what are the relations among them. So these 3 things are necessary so that machine can derive the inference from that data. That is the decision, what is the final decision, what is the classification, what is the prediction. So this is the output. Okay. So these are the input. This is the input you are giving to the machine, and it is learning, not in the just like that it cannot learn. You have to write an algorithm, and that algorithm will help to find the rules, the patterns, the relations. So this combination will help it to decide what is the output. Okay. So final decision or prediction or classification. So this is what the machine learning, the basic model. So in summary, the machine learning, given a machine learning problem, first you identify and create the appropriate data set. Data set is required. That car, that set of car, that set of bikes, whatever the set of vehicles are required. That is the data set. Unless you give the data set, it will not understand. Okay? So data set, then perform the computation, then required rules, patterns, relations, then output the decision. So this is the summary of the machine learning. Now we know these are the various type of, we have heard about supervised, unsupervised, then post learning. So these are the different type of machine learning depending upon the type of training data and the output combination. Okay. So if the machine learns from the labeled data, then it is called supervised training. Labeled data means the output is having the desired output is also known to you. Okay, the machine is given with that if this is the input, this is the output. Okay, so input is a car, and the machine is understand that it is also a car. Means that car tag is also given to the machine as the input. Okay, that means the car picture is given to the machine, and also car that tag is also given to the machine. Car tag is the label. Okay, so label associated with that object is called car. Okay, so that tag just like this. Suppose a car tag is written here, then that is called label. Okay, so car picture with a label, that is called labeled out. So if that is trained, then it is called supervised training. That means it is given with some supervision. Okay, so learns from the labeled data. So data is already labeled, that is called training data with some desired output. So just like example is classifying emails as spam or not spam, because it is already a supervised one. So it is easy, spam and non-spam. But unsupervised means that label is not given. That car label its tag is not given. Only that object is given. So how it will understand? Definitely it is a difficult one. So it is called unsupervised learning. So in unsupervised learning, training data without desired output. So it finds hidden patterns. It has to find what are the hidden patterns in the data and where the label is not given. So it has to find the hidden information, that is the difficulty. Okay, so that is called unsupervised learning. So here what we do, usually we do the grouping part. Looking at their similarity, we divide them. So classification, grouping, clustering, so this kind of operations we do, unsupervised learning. Then another is called reinforcement learning, this category. Here this category learns by trial and error. So give some trial and error or do some action through feedback. So take the feedback from the output, then do the action. Take the feedback from the output, then do the action. So that is reinforcement learning. So based on the rewards or punishment, accordingly we do the learning. So that is called reinforcement learning. We are teaching robots to work or play games. So that is coming under this category. Now another category which is created semi-supervised, which is just half-half. You can think of a combination of hybridization of supervised and unsupervised, where you have training data and but some very few desired outputs, not all desired outputs, but few desired outputs are also given, like limited label data and larger pool of on-label data. So if you have this kind of scenario, then you can go for semi-supervised learning. So this kind of category, this type of machine learning, it depends on what is your situation, okay? Accordingly, you use supervised learning method or unsupervised learning method or semi-supervised learning method where you have label data, then just directly use some supervised learning method. If you have on-label data, no label is given to you in the output, then you need unsupervised learning method. So in this way, our application of learning method will be depending upon the scenario created to us. So supervised here with those, you can understand this training data set. Okay. So this function, this is a function of these two, which is a car. So this is a classification task because it is supervised. And now if you are giving a car, it will understand as car. But if you are giving a bus, also it is giving a car. Why? Unsupervised. In supervised learning, even if you give a bus, it is giving you output as a car. Okay? Because that is the difficulty in supervised learning. Because it has only understood car and bike. You are giving data set, training data set, only car and bike. So features it has understood that 4 wheels are there. Okay? Some features it has extracted, and those features are also matching with the bus features. And it will understand it as a car because it is labeled data set. Okay, so data set is labeled as car and bike, no other label is there. So because only labeled data set is trained, that's why it will give wrong information. So classifier means it will classify between the different categories. So here suppose tiger class and elephant class are there. So identify the animal, then it will understand that it is similarity with the elephant and it will categorize it or classify it as an elephant. So that is what classification problem. Regression means if the output is a number, then it is a regression problem. So if the possible output values of the function are continuous real values, then it is called the regression. Okay, continuous real value. So it's a continuous real value in this kind of graph. If you are finding or output are there continuous value and real value, then it's a regression problem. So the classification and regression, these problems are coming under your supervised learning method because the decision depends on the characteristics of the labels, that is your label data, and we will define the experience. So this is also coming under regression problem, continuous and real values. Okay, so real output. Similarly, another is here, suppose a cancer and malignant. Okay, so this kind of tumor size. Okay, so this is the tumor size variation, and this is whether the category is 0 means benign, 1 means malignant. Okay, so 0 means this blue color, 1 means this red color. Now, how at what tumor size, up to what tumor size it is benign and up to what tumor size it is malignant. So in this way, a supervised learning is done. So it is found that tumor size, suppose up to this, it is coming under benign and it is predicting this size, more than that size is called predicting as the malignant. Okay, so you are having some misclassification because some blue colors and some red colors are overlapped. Okay. So here completely red color, here completely blue color. So benign and are completely separated. But here some ambiguity is there because of misclassification in that area. Okay, so this kind of problem may occur. So this is one difficulty in supervised learning. Similarly, it can be multidimensional. That means multi-features are there. So you will get this kind of problem. Suppose thickness, uniformity of cell size, uniformity of shape. So in this way, multiple features are to be observed. Okay, so tumor size and versus age with multiple features, you will get this kind of classification problem. So this can be multi-dimensional. Now unsupervised, because this tag is not given, okay, so this label is not given, so we do not know the labels or ground truth value. So that is called ground truth value. So here it can be a clustering problem, like it will see what are the similarity among them, because tag is not there, your label is not there. So it will understand they have similarity, so it will cluster. Okay, so that is called clustering problem. Or it will also see what are the other associated objects. Okay, so association rules are used. So association rules means, suppose with the car, some air freshener, some other objects observed inside the car. Similarly with bike, if helmet is there, then it is also associated with bike. So in this way, it will try to see the association rules in that machine learning. So association rule based machine learning will take care of other association rules. Okay, so this is how unsupervised learning is done. So this is about that clustering part. This is also clustering part. Okay, so if the data distribution is this, then it has to see the similarity and put the clusters. Now in reinforcement learning, what we do, we have an environment, and based on the environment feedback, agent will take action. Okay, so agent will bark. Here the dog will bark if you are if you are showing the stick. Now if you will change the action, then if you give some reward, then agent will change its action. So according to the feedback, agent will take the action. So that kind of problem will come under your reinforcement learning. Okay. So this is how we can just find the difference between supervised, unsupervised and reinforcement learning. So here feedback is there, mostly in control theory we apply this reinforcement learning. Control theory because always we have a closed loop control system and we have a feedback system. So there reinforcement learning works very well. So if you want to apply some machine learning problem, then reinforcement learning gives much better. Now how to frame a learning problem? So these are the basic things. How now, because before applying it to signal and image, let us understand how we can design a learning system. So because first we understand that a training data set is required. So choose the training experience, choose exactly what is to be learned, that is the target function, what we want to learn. Then choose how to represent the target function, that function which will map the from the training data set to the output. That function has to be first represented. Then choose a learning algorithm to interpret the target function. So this is how the overall the design of the learning system is done. So finally what we do, that from the environment and experience, the training data set is given, then learner will learn it, then with its knowledge it will perform improvement. it improves the performance. And you can test with that improved performance. So this is the basic design of a learning system. So these are about your collective classification and transfer learning. So transfer learning will study later on. And let us go further. These are not required. These are just an example. The format is actually very. Now we will apply the machine learning to some kind of applications, because as we discussed that we will apply to some signal and some image application. Okay. So let us start with biomedical signal, because we can understand the biomedical signal easily. Okay. And every day we are associated with so many biosignals, isn't it? What are the biomedical signals you have heard about this? So novel fusion-based time-frequency analysis for early detection of sudden cardiac death from electrocardiogram signal. This is the paper title. So here main contribution is fusion-based time-frequency analysis. Fusion-based time-frequency analysis. And here, what kind of fusion-based time-frequency analysis we have contributed, that part, let us discuss. So in this paper, these are the highlights. Transformation of pre-processed ECG signal is done as usual, but it is done in 2D plot, just like your spectrogram. So it is also done in two-dimensional plot. In that domain, the pre-processing is done. Then utilization of spectrogram, scaleogram. These are another one. Spectrogram and scaleogram images and their fused images as input data. Okay. So spectrogram is time and frequency analysis, and scaleogram that I will explain. So these two informations are fused. Fused means we are taking both the information and we are fusing as one information, fused to one information set, and then we are using transfer learning for analysis. Transfer learning, when we use in machine learning, transfer learning plays a very important role, where we want to reuse one kind of output in another machine. Okay. So suppose a pre-trained machine is there, we have already it is trained and we have given some raw data and we get some output, and that output we want to reuse in another machine. That is like the information is transferred to another machine. So in this way we can reduce the time of computation. So computational time is reduced by transferring it. So the transfer learning is used. So two contribution. One is your information is fused. Then fused information is put to the transfer learning model, and prediction of that SCD is done 60 minutes in advance, like 1 hour in advance, which is not done much. So 1 hour advance, how accurately you are able to predict. Okay, so this is the abstract of the paper. So first, always we write the abstract of the whole paper. We can understand from the abstract in nutshell. So here this study proposes a novel fusion-based time-frequency deep learning framework for early prediction of SCD by classifying associated cardiac conditions. Okay, so first ECG signal were denoised and segmented to isolate the clinically relevant patterns. This is always the pre-processed method. Then these signals were transformed into two-dimensional time frequency representation using spectrogram and scaleogram. Why we are doing? To capture complementary temporal and spectral information. Both temporal and spectral information which are complementary to each other. So we capture those information through this spectrogram and scaleogram. Then an average fusion technique merged these presentations, enriching these time frequency images with enhanced discriminatory power so that it can discriminate properly. So the fused images were used to train deep learning models, and performance was evaluated using subject-wise data splits to assess generalizability across individuals. So this proposed approach achieved a classification accuracy of 94.6%, because previously we saw the result that was 91 point something. So now we could get much better improvement in the accuracy. So effectively identifying cardiac conditions associated with SCD 1 hour before its onset. Okay, so this is the main contribution of the paper. So you can see the technical contribution part. Just the diagram part you can go. So this is about our introduction. In introduction, usually we do literature survey and what are the previous work already done and what is our contribution in the last paragraph. Then we have the written. And these are the why we have taken this part. No, this it must be there. The diagram, block diagram is okay. Access to your organization.
Okay, madam will actually download this from her institute, then after only she can share with you. Then you can go through that whole paper, because we cannot access, we don't have that access in our institute. So you have to wait for that. I will share definitely this paper. Okay.
And this is the attention. So this is how in this network it is used. So this is our attention functions for the let us launch the transformer model. So this is the final architecture. So here MRI image, here CT image, and CT image some information we are taking, MRI image different information we are taking. So here we are doing contrast enhancement, here we are doing edge extraction. So edges are extracted from CT image and enhancement which is done contrast enhancement in MRI. Then we are taking those information for fusion. So in fusion we are doing through this deep learning network. Okay. So these are the different deep learning network using both channel attention. So those will improve the network output. That's why we are using them. And this is the fusion. So the output of the fusion again, here the concatenation is done, and these are the like here we have taken the channel is big because this is a image fusion part. So we have taken the sizes, the content sizes are 3 cross 3 and different layers we have taken. So pulling layer. And finally it is pitched. So in this way, this is the proposed fusion network. So what we found, I will show you the output. This is another architecture. Here dense feature and attention module, transformer, attention module 2. Here edges are extracted, here contrast is enhanced. So all these are fused here, and finally the image is reconstructed as the fused image. So this is our architecture we have planned, we have proposed, and this is the output. Okay, output structure. Then we have did the training, model 1, model 2 both are trained, and these are the outputs. different outputs. And we could find that these are the two propositions and these are the previous whatever the research has been done, because we have to compare with their result also. So these are the two propositions we have done. And this is done by one MTech student. Current MTech student. So these are the quantitative analysis and these are the quantitative measures we have taken. Okay. PSNR, QCD, QAB, all these are quantitative measures. And we found that we could get little bit better out. So some methods we had used for some higher kind of image analysis. Another is facial expression recognition. So facial expression recognition also you can go for visible image and infrared image, because expression is a very important part and visually sometimes it is not visible to human being, but formal image you can see them in a better way. Okay. So formal expression will definitely change even if you try to not change your expression visibly. Okay. So because mentally if you are having some reaction, that will happen in formal image, but that will not occur here. So that's why nowadays formal image of face plays a very important role in identifying their actual reaction. Sometimes even if I am angry, I don't show my angriness, but inside me I am feeling that angriness, and that can be shown easily in formal image. So that's why nowadays lot of work is going on in this domain, but it is also difficult to get formal face image always. So here also we had applied some databases available and some CNN network, some feature extraction block, classification block, so we can use. So these are the various expressions: happy, sad, angry, surprise, neutral, fear, disgust. So whether 6 classes, 8 classes, many papers they are doing only 6 classes, and we have taken 7 classes. So these are the formal images related to yes, qualitative analysis and quantitative analysis. These are the confusion metrics. Now recently another part is added to the facial expression, that is called micro expressions. Micro expression means very short duration, your expression changes little bit and suddenly again becomes the normal one. So that is called micro expression, and that micro movement is studied nowadays. So that's why we also had started working in that domain, and there also we had applied this CNN network and we could find some better result. Okay, and for that this is the convolutional attention block, same attention block and your transformer module, both are used. Transformer. So this is how the micro expression, very fast short duration, but that gives you lot of information. So nowadays micro expression plays an important role. So why transfer learning? That we also, I told you, use just the pre-trained macro expressions model. That's why it is used here. And pre-trained models are already there. So take the output to the new task so that it can easily identify. So this is our proposed model in transfer learning. Then motion magnification block. That whatever little motion, that is again magnified, and that is used in this feature extraction block and used for classification. So in this way, lot of design you can think of in your domain, like what little ideas you can put into whatever the thought process you can put into your problem. Okay. So these are about your quantitative analysis, and we found that this micro expression also there was some better result. Already available, but very few database are available. You have to take permission from their university. Some database are available, not open. It's not open database, but you can take permission from their university. Normal image database is available open, but only 1-2 database, not much. These are very current micro expressions. So, say I started with one ATAC student, but she did a good result. We could publish in 2 conference papers, only 2 conference because they are staying only for 1 year, and we could not get time to write a journal paper. It can be extended a little bit, that can be submitted to it. Okay, so let us stop here. Some kind of now how the machine learning and deep learning can be used for signal processing, various applications, image processing.
Understanding, then data understanding, data preparation, modeling, evaluation, deployment, again. So this cycle can break many ways. Sometimes it comes that you go to data, then again you might do business understanding. Because when you go and explore the data, like the underlying hypothesis may not be correct, and that's where again you revisit, go to business. Then there is data preparation, because the type of algorithm you use, your data will depend on like how you prepare the data, how it should be like, will depend on the type of algorithm you use. Text algorithm will take text. Supervised will take, like you should be labeled data. Unsupervised, you don't need label. But it has like different algorithms will take it in a different way. So that is data preparation. Then modeling is what we saw, 3 different types of modeling. Can anyone tell me what are the 3 different set of category modeling? Supervised, unsupervised, and reinforcement. Okay. Thanks. So yeah, we'll go through this one by one, 6 set of processes, and this is very important because most of the problems, if you try to put in this framework, you will be able to solve it, given anything. So you see any problem related to AI, you just have this framework, but it's like a standard framework. You may not follow every time, but it can solve your 90%. This framework can help you in solving more than 90%. So yeah, business understanding. So again, I quantified the time. So 15 to 20% is for the spend. Sometimes even more when you are in a very complex setting. So let's say medical or let's say finance. So there it might take a bit time, but again depends on the complexity of the problem. The business understanding will take around somewhere around 20% time. So you need to have a clear objective. So objective is like, let's say you are making, I'll take the same example, like you're predicting the weather temperature. What is the objective? So is it like, I'll say a simple objective that I want to predict weather in the margin of 5 days. So if it is 45, I should not predict beyond 40 to 50. That is one thing. Like someone might say, no, I want more precise. Then there are, if it's based on the application, right, the agriculture. So if it doesn't rain, then you have to water it. Right? So there again, based on your use cases, the precision and how you set will depend. Then situation assessment, like to analyze the current state, how it is solved. So wherever you're going to apply, there is a way they are solving it right now. Right? You need to understand that. Then only you can say what improvement you can. Because the current system, if you're making some system by doing all this complex things, and if it's unable to build the current system, right, there is no use of it. Right? Then there are data mining goals, like it should be aligned like the business values. Then project planning is like video rate, if you are planning to complete in 3 months, 4 months, standard project planning principles. Yeah, then comes the data understanding, because once you understand the domain, then you should understand like the data. Like which data says what? Like there might be some flow, right? What does that mean? If it is like, there is some, let's say you're doing for the chemical testing, there are a lot of equations, lot of things, right? So you need to have a proper understanding of what the data is and what is the underlying pattern. How we do is like by a lot of statistical techniques. We do visualization. One simple thing I can say is like normalization plot, which tells a lot about the data. Anyone want about normalization plot? What does it say about it? No, normal statistical normalization. Okay. So normally it tells like how well your data is distributed. Like normally a normalization plot looks something like a scale. So it's a scale and words, and in between it is there is connection. So yeah, that is like data distribution statistics, then data exploration, and also the data quality. Because whenever there is a transaction system, right, a lot of things might happen. Like you might do a transaction, it fails, right? And when you are solving a banking problem, that failed transaction is not only, right? It might even get some impurity inside the system. There are a lot of, again, the quality issues that comes. So we need to be aware of that. Then comes data preparation. So in real world, if you see, the data doesn't lie in one table or one place. It might be in several places. It might be also in several forms. Some might be like in some SQL tables, some might be like Excel sheets, some might be CSV, some are human generated. Might be like if you are doing something to read the prescriptions, right? Again, it's a classical OCR. The input data is like handwritten. Right? You need a system which can recognize the handwriting and extract it. Similarly, now the future engineering. So once you have the data, how you combine it? So we can future engineering is like each of these that I said. The input data is called a feature. So when you are predicting a temperature, right, you are giving passing humidity, or you are passing the wind flow. So each of these is feature. Now if you combine, simple example can be like I had to open, or I just find a rescue around. As simple as that. So these are like the features that we do. That is called feature engineering. And data integration is nothing but combining them all, because your model takes just one format. Like the data in just one table. It should be there. A single, let's say, each example should be a single row of data. And until this is the data preparation, you can see it takes 50 to 60% of time. While solving any AI problem, algorithms, everything automated, the data preparation itself takes the longest amount of time. Because as I said, garbage in, garbage out. The data is not good, your system won't be good. Your AI system is as good as the data is good. That is something called as data centric AI. You can read more on it. Then comes modeling. So technique selection. We saw this before, right? Technique selection. How many techniques are there? Three. Yes. And then test design. So we generally divide the data into training, validation, and test. So what is the difference? Training is major part. Let's say I'm saying 70% goes for training. Out of rest 30, 15 is validation, 15 is testing. Validation is something we keep it while training to benchmark on that data. And test is something that represents the live scenario. So ultimately, whatever metric we want to achieve, let's say I was saying about the temperature prediction, right? I want plus minus 5. So it should count. It should give that result of plus minus 5 error in the test data. And that's how model is accepted. There are other techniques also. So let's say someone today said Netflix searching. So when those kind of systems are verified, there is something called as offline and online test. Offline is something you can calculate. To calculate some error, percentage error, there is RMSE, B square error, common. But online is something like, when you give it to the users, they use it. And whatever impact you want to achieve, you are achieving it. That is the online session. Now we'll go through this in next few slides. Then model building. Like you build a lot of models and see which is giving the best results. Whatever success criteria you have set earlier, if you are able to achieve that, and that is what I can assessment. And then evaluation. Evaluation is like there are business objective evaluation. So like the temperature prediction, Google gives you that, right? Now Yahoo also is giving that. Same thing many people are giving. So the business validation there, what companies they are evaluating, whether it is improving the hits or not. So or it is bringing new people. So if you are giving more accurate, right, people will compete. So those are the like business metrics. Then process review is just common remain the activate process. Then deployment is so whenever you're making an algorithm, right, you train it in a system, right, which is very local system or somewhere in server. But whenever it goes to the production server is nothing but your apps, right, mobile apps, wherever it is working, that is the production server. And if the AI algorithm is going there, before that, a lot of deployment tests are conducted by see few of this. And there is risk assessment. So one classical example of risk assessment is, as I said before, it should not give something worse than the present system. So that is one thing, or it should not lead to something negative of what you want to achieve. Let's say you want to achieve the footfall on your website, and now with this new feature, it is decreasing. So that is what you have a risk assessment. So that needs to be associated. So the experiment that we do should be controlled. And deployment, as I said, whatever you speak into the system, your apps, wherever it's deployed, it's called a production system. Now, whenever an AI algorithm is deployed, there are a few things that we do like monitoring it, maintaining. Knowledge is nothing but if you have documentation, someone can read it, another AI scientist or engineer can read it and rework on it. Model monitoring is like continuously monitoring the performance. Like let's say in the temperature prediction, you want to achieve plus minus 5. But it should be continuous every day. Like you predict for tomorrow you get the actual temperature, you evaluate it again day after tomorrow. And it should not go beyond that. These are all real life cases. So let me know before that we can also rewind whatever we learn. And whatever we learn, all that application. Many examples I give, same thing you will see, but we'll try to go deeper in each of these. All these are like proven case studies from topmost companies. Okay, it might be in some finance or it might be in internet technology, e-commerce. Okay, so let me know it out in the whole theory part. No. Okay. Okay, so here's the first one. You all know what's Siemens, right? So predictive maintenance, I was talking just before a minute. Just read the problem statement. I have pen and paper, so we will try to solve it in here with the list DMD. But there we will try to focus on 4 parts. One is like what is the data required. Second, how will solve it. Third is what can be the challenges. Fourth is what are the success criteria. Okay, 4 things. Each problem, each of the case study will try to solve based on this 4. Like on these 4 sections we try to do. Okay, so have you understood the question? Here, let's say the machine needs some data. Okay, let's count the data. What kind of data is there? Follow. Correct, supervision. So here like sensor data and we need all historical maintenance record, the operational data. Then equipment specification is also one thing because old instruments are more prone to high maintenance. Right? And there is solution. So how Siemens implemented it? So they put 200 sensors, 200 sensors, and it might have increased now. 200 is also not enough to predict, because if you want to improve the sensitivity of prediction or accuracy, you need more and more data, and it should be captured at, let's say, every second. Yes, and algorithms is mentioned. Random forest neural network. So, random forest is statistical bit traditional method. Neural network you might have heard it. So, represents the neurons that we have in our brain. So that is used to train such kind of model. Then they generate the maintenance error. Now tell me, what is the challenges in solving this problem? What could be the challenges? No challenge, everything is simple. Collecting data itself. Identifying 200 sensors. The 200, reaching the 200 is maybe even 5 sensors is very difficult, right? Identifying where to put them.
Identifying the pattern.
Pattern, yes, there is also one challenge. We are working on this success rate. Success rate. What metric you guys? You build algorithm, but how will you know that it's working? It's able to do what you wanted to. Or there is no ability to lie somewhere in your computer that algorithm no use. Okay, so problem solving and decision making, like found idea in fact that decision making is one of the key skills required by AI. Now here are a few examples of AI in the real world. Let me know if you're not if you don't see any of this in the real world. Right? We already have all of them, right? Voice assistant.
Alexa.
Yeah. Now you have all, like if you have Android phone, you have Google Assistant, and even the AI models integrated. Recommendation system. Can anyone give an example of recommendation system?
Netflix.
Before Netflix, we are like now
YouTube.
YouTube.
Yeah.
Taking common example is Flipkart and Amazon. Whatever you search and I search, it might show different results. It is customized to each of the individual person. Autonomous vehicles, you know, right? There's this one company famous for it in India. A lot of small companies going on. Still, it's very difficult for a human to drive in Indian roads. Forget about it. Medical diagnosis. Yes, medical diagnosis, a lot of things, right? Let's say ultrasound, right? What happens in ultrasound is the beam of sound is like, again, it reflects back, right? So the image is predicted, it has a algorithm inside. It has some intelligence. So when it started way before, like somewhere in 1970s, 80s, and now that they say now it's not out yet because of some medical restrictions, but they say that AI can replace the experience of a 20 years old doctor in diagnosis. So the kind of images which a doctor can recognize, like some critical things, identifying any kind of like some stone or let's say tumor. So whatever like 20 years of experience is replaced by AI, but yeah, it's not there in the market yet, but we are there. And industrial robots, so you will see like if you go to warehouses mostly, or even if you go to a lot of industries and if you ask, so the amount of manpower needed before 30 years and now is reduced significantly, but the output has increased by 10 folds or 100 folds. How it has happened is again some intelligence system. May not be AI, like very responsive, but there is some algorithm in it. There is some motor, there is some like PLC is also a kind of automation. It's not intelligent, but it has automation. It can sense from the sensor and make it listen, right? Let's say I'm saying that if the temperature of the room increases above 25, then go to the AC, right? This is also like, you know, AC also systems are there. Okay, now we'll go through the AI evolution. So, how to get over the history, but this is how it started. So, as I said, it started from 50s. Because as I said, the basic building block of AI algorithms is nothing but stats, maths, and calculus. So, like Alan Turing, he employed one AI system. It was not called AI system, but it was used in World War II. So that time, if you, how many are there from signals? Anyone from signals? Signal processing communication? No one. Okay, so in signal there are like analog and digital. So that time, you know, only analog signals were there. So that is very easier to hear. Anyone can trace it in analog signals. But those information which they are giving us coded, he was able to decipher that code. He created a machine because it's World War II, right? Someone is sending some information, if you interpret it, then you know how to protect yourself. So he created a machine by deciphering the messages, they were able to convert the signals to original messages. And it happened in World War, even before 50. So there is something called a Turing test also in the name of Alan Turing, which we do like, you know, for identifying bot. So what happens is like, you know, a human is there on one side, another side there is the bot which replies to that human. How much time does it take for a human to identify that the other side there is the bot and not human? So that is something called Turing test. So yeah, that's how it started, and then a few AI programs came, but main problem was, you know, that they are only limited to lab. And then we had next set of revolution where, you know, we, like I said, had medical diagnosis system. Those are again not that intelligent, but yeah, it had some algorithm in it. And but mostly it was again it's a rule-based system, like I said about AC, right? So even the temperature when increases above 25, make it below 25. So it's called rule-based system. But it has intelligence, right? It is able to do itself, right? It is able to take some decision. So it's in present day, you say AI, people may not say yes, but that time it was the intelligence, the level of intelligence we had. And then came the statistical things, like statistical learning. There are a lot of statistical algorithms. Let's say probability. So, what is the probability of rain in July? Can anyone tell? Out of 10 to 100, what is the probability of rain in July? 70. What is the probability in March? 20. Yeah. So that is, so statistical, like, you know, statistical analysis, like there are more advanced techniques, but something like that. You know, you have the data, you have the numbers with it, and you have the probability, and that's how the basic systems came. And then, you know, there are trade scoring for prediction. We will go through some of these use cases which came. And the new milestone started achieving near about 2000. There's something that happened in the world of computers in 2000. Does anyone know that?
Y2K.
Yes. Can you explain what is Y2K?
Some programming work.
Okay. So in Y2K, what happened is led to a lot of memory loss, because what happened is, like, you know, we had like 2 digits, right? 92, 98, and year. And when it came 2000, it was 0. So it went back. A lot of data loss. So that is what, but again, after that, the industry recovered, and then we started having deep learning revolution. Like deep learning is like neural networks, you might have heard, like, which are very complex systems, requires a lot of data, and something like a GPU to train. Then in computer vision is nothing but image processing. I think we might have a session today morning, right? Image processing. So that is computer vision. And now we are in the modern era. where we have all these algorithms. One is that ChatGPT, all those. So the base of ChatGPT started having, we got that base from the bird, which came around 2018 by bird. So if you see like after 2019, like have you seen that if you ask a question or some search in Google, right, you get the same question and answer. Has anyone seen that? No, then go and search and see that it's there. So that is something called as question answering. Given a topic, it can form the question, it can answer that happened or because of what. And now they're using like, even like now we have a lot of these advanced algorithms, so based on the complexity of the search, they might call it work model, or they might call it like GPT series model. And then in the current day landscape, like we have AGI. AGI is nothing but whatever processing is happening on your computer, like on the phone, that is the AGI. Because AGI is where we operate with lesser memory but similar kind of intelligence. So there is a person on Gemini, you can search it, which can run some very small things, and you can download it in your phone and you can use it. And so the data is correct. Okay, retina is eyesight. Types of food system. Food system, okay. Food system, what is it? Due to which diabetes? No, just read it. We want to detect diabetic retinopathy. Retinopathy is when the retina is going to damage. Retina is white.
Retina of a
Retina images, right?
images of a healthy person and like figure that out before damage and after damage.
Yeah, so both cases we need, like someone suffering from diabetic retinopathy and someone not suffering, but he may have diabetes. That is one thing. And how you solve it? What kind of algorithm we need? Three categories. Sorry? See, you have data like you say that who has retinopathy, who doesn't have retinopathy, so it's supervised. Okay, so that's correct. Retina photography. We also need medical record, then clinical annotations. Annotations are nothing but there will be images. Doctor, ophthalmologist, mostly access it, whether he has the disease or not. Then few demographic data also. They use more like 28,000 images. And yeah, for the images, CNN, for convolutional neural network, is one of the family of algorithms. So like ChatGPT, you see there's GPT family. For image processing, we have CNN family of algorithms. It has inception G3, but now again a lot of things are common. And image is something where many people have achieved 99.99% accuracy in few of the tasks. May not be in this task because it is something that's not on the image recognition. So in image recognition task, where you're using like given image, whether it's matching to the one that you have a system on. So there the achievement is around 99.99%. But yeah, in medical cases, because it's retinopathy and you have predicted early diagnosis, may not be there. But yeah, this is one of the solution. Okay, here are like few challenges encountered, like, but yeah, they are able to achieve 97.5 sensitivity and 93.4 specificity. So it leads to speed movement cooperation, like general things. Okay, let's move to the next one. Fraud detection. Has anyone ever raised any fraud? UPI card or one?
If we share the OTP, then there is a chance of fraud.
Now, see, in international transaction, have you done any international transaction? Doesn't need a OTP. If I have a record, I will do it. Just requires the CVV number and your card details. So that is why whenever there is OTP also there is fraud going on in here, right? They will say that they are verifying it something that is not that or anything of it. Not our part to solve it, that is for the shipment to solve. But those kind of transactions, where anything, or your card is lost. Okay. So what happens? Let's say your card is lost, right? You will block it. If you don't block it, it might be found somewhere in the, let's say, Nagaland, right? If I am doing that transaction. Now the system says that you only do transaction in Odisha, right? We never do go to such places. Still they can block it. That is an anomaly, right? So that is how the kind of systems are created. I said in simple words. Machine learning doesn't understand those things simply. There are a lot of things that is considered. I consider like location, time, type of transaction. Suppose there is one guy who is not even transacting more than 1,000. The one of role is converted to 50,000, right? That is also an anomaly. Okay, so what kind of data we have? Simple transaction data, right? Transaction data and there was fraud happening. Okay, now here, what are the challenges? False positive, but in data challenges, there is one very big challenge in such kind of thing. How many times, like in a group of right, 30 people, no one has faced fraud, right? Security is one of these. In data challenges, like the fraud cases are very less, maybe 1%. The whole transaction, let's say you take anything, you take phone pay, PayPal, GPay, the fraudulent transaction may be even less than 1%. So, and that is what you need to identify, right? So your machine learning, your model is seeing only good cases. So if you ask the probability then of having fraud is 1%. So maybe it will miss a lot of cases, right? So that is the one of the challenges of the system. So yes, transactional data, then behavioral patterns, then network analysis data, like network is like which network the payment happened, that is the network. There are a lot of things. They are already using deep learning network, but it can be solved. This is very advanced paper, right? This is a recently released, not recent, like last few years. 5 years back or 6 years back, if you see, they're not using this advanced algorithm. Like yes, random forest, execute, if you see, those kind of algorithms can also solve it. Yeah, challenges. Okay, another this is the first one. If you see, that is the main challenge, implementation challenge. The transaction happen in 1 second, right? So you have to decide below 1 second time. So if the model response time is in 2 seconds, you are gone. Till the time you are deciding fraud, the fraud will happen. So that is why one part that I considered fraud was like deployment. So even if to make very nice model. So one example I can give, let's say you have a camera which detects your face, but if you have a model which takes 50 GB RAM, or let's say 100 GB RAM, can you put it in that camera? Or if you even put it, what is the cost of that? 30,000-40,000 more battery, right? Depending on the hard of 1,500 to 2,000. So they might be making it 200 to things like that. So yeah, that is one of the things, like when you solve the problem, you have to consider that where it is going to use. Like is it feasible to even use the big setup, like or a big model? So a sanction rate is like fraud detection rate. So they are able to detect 99.5% of fraudulent transactions. But again, it's internal thing. I won't buy this. I don't know if that is possible to detect 99.5% of fraudulent. But yeah, this is what they're formulating their paper. False positive rate reduction, because they're using advanced algorithms, so they might be able to do this. then person's pay cost saving, and mostly cost saving is not the customers, but what they achieve is customer satisfaction. Like PayPal is one of the what I'll say most preferred way for international applications. Right, very simple.
Well, cost savings in just not for saving.
Seven engineering prevented fraud is right for users. So that is what they do. Great companies put that kind of thing. They will say you 1 rupee, but 1 million users they say 1 rupee, so they will write they say 1 million. But because of that, there are the customer base will increase by 20%, which will give them revenue. Like when WhatsApp started, right, they were charging $1, right? Now they're not charging when Facebook one. But with $1, they're let's say 1 million users, 1 million per month. Right? So that's how the microeconomy works. Then autonomous driving. So that is like very challenging. There is like a lot of scope in it. Many people are interested, but we are not there. But yeah, somewhere they use it. The targets one, but yes, so what kind of data we need? It's very easy. You are driving with what data we need? Quantify numbers because machine need numbers. It can't understand language. Only ChatGPT can understand, but it can't say. It can't guide us.
Omega C. Then that part will remain there as is, and remaining will be subtracted. And then if we go for inverse Fourier transform, so I will get it in oil version of the signal. Okay. Now, what exactly is what is the features representations of the features? So it's a representations of the image, and sometimes in volume is a function of or move from the image into another node. Now, the representation can be done. So before I do these representations of this image, so I want to give one example. Say how many ways we can describe this room. The construction, say it's a civil problem, then how many ways we can construct this room or represent this room. Okay? So the earlier method is using bricks, right? So number of bricks stacked together and then using sand and cement we are building this row. Alternatively, can we make with slabs? So instead of bricks, we are taking a wall. So imagine that wall. So only one. So is there this room can be combinations of bricks, right? Different sizes of bricks, different volumes or different widths of bricks. Or we can describe this room as a combinations of walls, floors, and roofs of clay, right? Or we can, if we want to describe this whole building, so we can describe with the combinations of rooms, right? So what is essentially when we are describing the same object with different ways. Now this is a different level of sensations that we are making it. So for example, if we want to describe this image, so we can take some straight lines, say piecewise constant, but varying with different orientations, right? So we can imagine certain features like, say, the pixel values are going like this and then coming like this. So it's a Gaussian curve. And then that Gaussian curve is oriented in different ways, right? And then if we combine all these, then we can develop this space also. That is one level of representation. Then the other level of representation, combinations of these regions, we can call these as the regions. And combinations of these regions can form a part of the face. And then this part of the face can combine and get the whole face, right? And then we can also represent that instead of taking these parts, we can take number of people's face, and then I want to represent one person's face. how can I represent them? Say for example, I have taken 5 faces from five different persons, and then I want to represent one face out of them. Then how can I combine these images and get that face? So this is very simple. Then I will take one weightage to that particular person's face and 0 weightage to other person's face, and then add. Right? So that means I will multiply 1 means that same face, and then remaining 0, so I will turn to 0, so that same face. Then I can represent this particular person's face as 1 and remaining values are 0. So a vector with 1 at the positions of that particular person's face and 0 for the other persons. And similarly for another person, 1 at his or her place and 0 for another place. And now what I am getting? I am getting the dimensions of a space where this 5% space can be represented as a point. Are you able to visualize? Great. Right? Now, if I move for lower level of features, then what I am doing, I am dividing each dimensions into number of dimensions. Right? And so I am making a bigger space with more subtle dimensions. Okay? Now, what advantage I will give? So if I move for the lower level of representation, I need to have a number of non-zero elements to represent this value. And so my vector representation will be B. Why? If I move for these face-based representations for the face, then I will get a very small value, only 1 for that particular person, 1 for another person. So I will have my non-zero vector will not be B but 1. So the representations will be less. And then if I work on that representation, since its length of the representation is less, so my computations will also be less. Okay? And you see that we will come to that point, then this is again converts to one set of operations, which is the signal processing and signal transfers. Now for facial representations, what are those features? So we call it as a hard type feature, and this is nothing but the regions. So in one rectangular box, one region is black, that means 0, and the other region is white. Okay? And now, if I place that strip on the eyes, so what happens? That whenever we are getting illuminations of the eyes, so this part remains low region, low pixel values, that is closer to black. And these cornea portions or this region of the nose, those portions are bright. So if I use these second features, where we have these black, white, and black, so then this will extract, this can extract this region probably. Okay? So then, so that means I need to know then how many of them are required to represent these features. Okay? So now to find that feature value, what we do? We do go for the what we call inner product or dot product in vector space. Okay? So in functional space, the corresponding term is inner product. In vector space, it is the dot product. And what is this? It's very simple that element wise we multiply and then we add all of them. And that is nothing but the dot product or the inner product. And now in the region matches, so what will happen? This value will be high. If the region does not match, this value will be low. And so we can segregate these regions in terms of high and low values. And since these features can represent a face, so it is likely that for the features this value will be higher, and for non-face it will be lower value. And so we can segregate. And then our task will be to find a differentiating line or plane between those points. Okay? Now, how to calculate this? So you can see that every window can move and compute for each of these windows, we'll compute these features. And then we'll see that those features can form. Say for example here, we have F2H, tuning F2H or F3H. So this is nothing but the two rectangular feature, vertical, three rectangular feature, horizontal like that. And then each of these features is creating a dimension. So we have say this is for this top one, two rectangle feature, this is for three rectangle feature, this is for three rectangle vertical features like that. And then this space is represented as a point in that space. Okay, and then for phase we have some clustering of the points in this certain region between the minor, and for the non-phase we get some low value or different value, and then we can have a boundary. Now in certain cases this boundary will be linear, and so we can get a straight line or plane or hyperplane. But in certain cases the data represented in that space may not be exactly linear, so we need to have a non-linear boundary in there. And in that case, what is needed? So before we move forward, there are options. Then we develop a non-linear filter to find that boundary using these currently used techniques called DNN, CNN methods, where we have non-linear functions inbuilt into the system. So that in terms of the activation function. Whereas there are some methods where before you move for nonlinear classifications, you can transform that space into another space to a nonlinear function. That will linearize your data, and then you can find the linear length between these two things. So now you can see that white thing is represented as these linear combinations of these H and K. So this H and K is these feature values with the signal, the image signal is same. And so for Fourier transforms, this H and K can be exponential function. Okay? And now you can see that this H and K can be any function, H and K. And so if this function is a wavelet, then we call this is a wavelet function, or the feature calculation. So you can see this is doing multiplications across this name, and therefore we call it as a non-convolution. It's an inner product. Okay, and so this inner product operations is done. So one thing is the feature value of that. And so if we go for this Fourier transform, then this exponential function is the signal. Wavelet transform, you will have the wavelet function as this H and K. If you want to do say discrete cosine transform, this H and K will be discrete cosine function, and like that. So you change that H and K, you will get different transformation. But essentially, all these operations are inner. So again, so apparently at a physical level, we see there are different methods of signal transforms. But all of them combined together, the actual model is inner product with a function which very often is termed as a kernel or basis function. Okay? So H and K is a kernel of the transformation. So as it is a window through which we want to see the outside world. So now, what we are doing, that we are having a phase image, and then we develop a feature vector, right? So now, the people came with this idea that can we build a silicon fabric on this, which will be very general in nature. So like a language. So I am only fabricating millions of languages on this silicon wafer, and then this language will be unconnected initially, and then we want to connect it and that can be done through coding. Okay, so we have different languages spread here, but they are not connected. Now we are connecting. So that connection is done through coding, with VHDL or VHDL coding we can make. And then we will down one function, Boolean function or Boolean set become that. Right? So that is what is developed. But in this case, it is not just an entity, but what we call is called the CLB's configurable logic block. In some manufacturer, other manufacturer like Ontario, they are talking about the logic elements. Okay? So the terminology is different, but they are same. Okay? And so inside this, we have this configurable logic block, and inside the configurable logic block, we have what we call it as a flip-flops, but in the form, say, so we can make it in this form, memory unit. So then memory units can be used. So for example, if we want to, so we have a mouse and the LUTs. Okay? So the basic elements inside the Srinix FPGA is we have LUTs lookup table, which is nothing but memory. And then along with that memory, we have one mouse. Now the selection line of that mouse will decide. For example, I am giving very simple one. So if you do not have any experience with it, so we want to develop it. And okay, so what is the truth table of the AND gate? So we have two input AND gates. Then 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, and then 1, 1 is 1. So what we are doing, we are storing these zeros out in the arrays. Okay, 0, 0, 0, and 1. So we need 4 locations in the arrays. And this 4 location is connected to the mouse unit, the multiplexer unit. And then to select one of them, how many bits we need? 2, right? So 2 bits. So those selection line now becomes the input of the AND gate. So this name. Now if A and B is 0, 0 is location LED will be connected to the output. Right? If it is 0, 1, then next location. Then 1, 0, next location. When both are 1, 1, then fourth location will be connected to that. And essentially it is giving is mimicking the truth table. And now the truth table being a very generalized representation of any Boolean circuit. So in the Boolean circuit, if I want to implement on this, so what I will do, I will only store the output of that Boolean circuit into the LUTs, and then I will connect the input signal to the select line, and it will provide the output of the Boolean circuits by selecting the outputs. Right? So that is the basic concept for this generalized logic block inside these FPGAs. Okay, and then we can build any out of this logic block. We can build the digital electronic circuit, arithmetic circuit, and all these circuits on a parallel basis. Now, so we can have this. So not only these logic blocks are available, but also we have some specialized blocks. So for example, we have DSP slices. And what DSP slices contains, then we need convolution operation. DSP filtering convolution. So convolution operations we need. And what is convolution operation? So in case of say whether this inner product and convolution operations can be connected, correlated, and in what way? Right? So if we see that convolution operation is essentially the flipping of the kernel, the H function, that HMK, what I have told, and then shifting it, and then multiplying it and adding together. So multiplying it and adding together is the kernel, right? And then this kernel is shifted or flipped and then shifted. So flipping, that means negative of that, And then with that, if I go for inner product, so contribution is essentially combinations of cleaning of the kernel and then inner product, right? And therefore, we can have a hardware component directly. So we will be calling it as a MAC unit, multiply and accumulate. So this MAC unit is nothing but the convolution operator embedded on this platform. And so you with minimal configuration, you can execute the convolution operations taking this unit from the DSP slices. On the other hand, you can also do it with the CLBs. And if you do it with the CLBs, then it is distributed over the IC. So then we will be calling it as a distributed structure or distributed computation, right? And if you go for the DSP slices, then it is very localized computation. So your computation unit is very highly localized inside the chip. So depending upon our requirement and availability of resources, then we can decide that where to do which computation. And then for we should mitigate different performance requirements. Okay, so now why we will go for this system on chip. So why in one hand we have the FPGA where we can exploit the parallel operations or concurrent operations of any algorithm, and in the other hand we have the processor which can execute in the software mode. Like we use this MATLAB, C, Java, all these languages for that. And so, and then we are trying to combine these two, right? So we'll see that they are not. So let me go to that particular slide. So we have certain processors which execute this operation sequentially. For example, if we have one ALU in the processor, so you could replace that ALU by, say, oven, say in our daily cooking and requirement, right? We have only one oven and we have to cook multiple times. Then what we do? We have to do it sequentially, one after another. Now I have two ovens, gas ovens, and then what we can do?
At a time.
Two at a time, but not complete one, right? So we can do, say we have to do for 6 curries, then 2, then 2, then 2. Then what is happening in 3 units of operations, I am fulfilling the complete operations. But earlier we have to go for 6 units of operations, right? So if I take, imagine it's time unit, then 6 units of time in one unit, while it is sequential. In between, so resources is less, but not exactly one, more than one. So then I can do it in a 5 times. So that means I can partially go with the sequential, and so 3 units of time is required to complete the task. Then if I have it, fixed 6 units of ovens, then I can simultaneously in one go, I can cook everything, right? But this is not always possible because the availability of the resources are not always the full. Not only that, the algorithm which we are trying to implement on the hardware. Okay, so what we are doing when we want to measure the actual response time peak, then in the PSD we have a peak value by the rate, and so what is the actual maximum peak? So that we can do by multiplying this factor for n is the number of samples, and then into the bin width. Bin width is the histogram intervals, okay, per sample. So this number of samples is the total number of samples out of which this histogram is constructed. And so if we multiply this, then we will get the exact response time value for that particular instances of the sample. And so now our task is to compute this bin width or estimate this bin width from the data. So whatever we have used here, this estimation is preliminary estimations. There are refined estimations also. like say we have a diagnostic estimations, we have not applied. So we have roughly plot and that P weight is the response time max minus response time D by the recover of this thing. Now by recover of it, because with the increasing number of samples if we increase, so this P weight must not include the noise that is exposure counts in the histogram base. So as we are going for widening these histogram base, so more spurious counts will be coming. So to restrict that, we have used this. This is a heuristic estimation. So by it. And then this, what is the sigma value? So sigma value we have calculated, and then this rate we have count taken and 6 into sigma. So that 99% of the values are within this spread. And therefore the PhD is now computed as N, which is number of sample, which is fixed also, into the mean width. Mean width is variable, where the actually it is varying in the maximum and minimum range of this response time. And then sigma, again sigma is the variable in there. So if we are estimating the sigma by this 1 over n, and over summations of RT square, RTI square minus summations RT whole square minus. Okay? So this is again estimations of the variance. And then our task is to compute the sum of RTI square and then sum of RTI square by n. Okay? And multiply. So we have multiplied this histogram spread calculated by this, so our hardware would go with this computation structure. And then on the other hand, we have this RT sum squared and all this. Now we can observe that all these inputs, all these computations, sub-computation unit, so that can be parallelly computed. Okay? And so our programmable logic fabric, where we have multiple CLDs, we can configure those CLDs for each of these computation units separately, and then we can simultaneously compute. So by that, this PhD calculations can be possible. Okay? And so the elaborated one. So we are also finding on the raw data, so the response time collected, we are finding the max RT and mean RT, and then sum and square RT. So which can be connected to this one. Okay? So max and mean RT, so maximum and minimum calculator. So there, this is the elaborated circuit. And after that, we can go for the training data. We can introduce data to make this model. Okay, this model. So where we are using the training data to find the active hours of the subject from these PhD values. Okay, and so that training data we introduce in our architecture in this, where we have the memory, small memory and local memory here. And finally, it is giving us the active hours of this subject. So that means if the active hours is more than say 16 hours or so the person is definitely going to be lower alertness level very quickly. Okay? And so this is the estimation performance, where you can find that this alertness score standard deviation is very less, so that means the measurement is very precise in nature. And then we also find that high alertness level and low alertness correlation value with the sleepiness scale. So you can see that SSS, which is Stanford sleepiness scale. So which is subjective one, but since subjective one is often neglected, so we are going for objective one. But we are finding that with the sleepiness scale, this is highly correlated. And as it is low value, so these values are also low. And then we can see that two graphs are there, so that means it is able to distinguish between the lower and higher alertness level. And again, to measure the performance, and particularly on the embedded system, this realization is required to measure that how much resources needs to be used from these available resources. And then our target would be always to use less amount of resources so that the future augmentation can be accommodated later. Okay? So you can see it is quite good enough. And again, what we can do that if we want to connect these two units, that means one is this choice reaction test-based unit. So we should be activated at the beginning. So this is under the context of driving situation. So when the driver is starting his vehicle, so before it starts, it should be assessed like whether that what is the conditions of the driver. So if it is not alert, then he should not begin that vehicle journey. So we introduce them at the beginning, it will be choice reaction test, we will decide. And then once the driver is accepted for the starting, so then it can go with the purpose based method, and then this will continuously run on the vehicle so that we can avoid any kind of accidents. And then combining these two, again consume the resources, and we need to see whether this is available or can be accommodated within this particular hardware where we have used this gene based system. So this gene or gene based system, so they have the same system on the gene, genes that are found in the series. Okay. So this was our work on this paper, that we basically try to compute this PhD which we had proposed earlier. And then we combine these proposed circuits and this circuit together. And some of the component is done on the hardware accelerator, that is FPGA blocks, and some is running on the ARM processor. So which are basically slow process, those are done in the process on the ARM processor and user interfaces. The inside is the feature which is required to be faster. So those are running on the hardware accelerator or programmable. So this way we have partitioned the software and hardware component and executed on the system also. So these are some references for this particular paper we went with. So I think you can discuss if you have any doubts. The law that real-time FPGA system. 2025 we have published paper. But this paper is based on the earlier paper. The base paper I have discussed. And any question related to that work requirement, work pattern also can be addressed. Then, so this was a part of that project here in this project. So where we are working. So it was actually, so although I have put it in a few slides, so it took long hours because we had to keep many tasks was the experiment to get the data, completely simulation based work, analysis, signal processing, which is related to this part. So this part is related to the data analysis earlier. This one. And this one is analysis of that data. And then finding or proposing this index for this analysis. But then we need to validate it. So how to validate it? So again, statistical methods. So finding the correlations with the events or the phenomena. Or the differentiating capability with means of these two states. So that need to be validated statistically. And once that statistical validation is done, so this is statistical data analysis, this one. Then we went for developing the hardware. So after developing the hardware, we also need to validate that because we have a little bit changed these formulations and we will be suitable for the hardware. Then we need to also find that whether this is the output of that is precise and coded with the events. And then as we are targeting the embedded system or portable system, so we also need to think of that less resource usage. Okay? Not only less resource usage, if we do not have a source of power except battery, then we also need to think of the power consumption. So it should be low power consumptions. And one of the ways to reduce the power consumption is to develop an architecture or algorithm which will require less number of activities. Okay? So like for example in embedded systems or one processors, we can find that day by day the clock frequency has been increased. Right? But is it always possible to increase the clock frequency without limit? Or even if, say, if I want to run some certain system in gigahertz level, can I do it with a battery? So point is no. So I need to have a continuous power supply. Otherwise, this battery will be drained very quickly. So then I cannot artificially increase the clock frequency of the system. Then the question comes that whether I can do it with reduced clock frequency or not. Then one option is that if I reduce the clock frequency, then I have to multiply the processing. That means number of processors must be increased. Okay? So then whole task divided into subtasks, and subtasks which are decoupled, not connected or dependent. They can run on concurrent basis or parallel basis. So then each processor can run with slower clock, but it will ultimately fulfill the real time. And by what real time we mean, that which is executing its work within an affordable time limit. Now what is this affordable time limit? So how it is decided? So I generally give two examples. One is say on the power line. When there is a fault, then we need to respond or treat the device within say microsecond order or so. So that means if I develop a digital system to operate this, then my digital system must run within 1 second of the event occurrence of the event. But there are certain systems like say predictions of event, which is very complex and requires a long execution time as long as say 1 day. But it is predicting for say 3 days ahead of this weather. So then 2 days there is a gap. So if I know the predictions 2 days prior to that, that also be usable. So that means this real-time constraint is actually given by the user, not by the system, right? And this is not dependent on the magnitude of the time. So even if something is taking 1 day time, it can be a real-time system, because it is depending on the utility of the system, right? So very often we have in these transactions that real-time means it should be very fast, but that is not true. Okay. So all these issues must be thought during the design of embedded system.
So in parallel processing, you are using less current or you are reducing a bit. Means if you are lowering the clock rate, then using parallel processes, I think the power is consumed. Less the benefit is of the heat product. It is true or actually consumes less power.
Actually, the concept is that parallel time I am reducing the activities. Okay. Now you can apply in your everyday life. Okay. In 1 day, you want to do say 20 tasks, or in 1 day you want to do 10 tasks. So which one will consume more power or energy? basically and total accumulation. So which will be used. So if you go for lower number of terms, okay. Now what is your partners? Right, your partners. That is not simple enough. When you are speaking, what is your partner? And when you are running, what would be the partner? So more power, more energy, more clock wins. So you are basically increasing your number of activity per unit time when you are running. So number of wins are increasing. So you need more power in every cell. Right? So that's how this concept is. Okay. They thought that real-time behavior system. So in 2025, we had published that. But this paper is based on the earlier paper. The base paper I have discussed. And any question related to that work requirement, work pattern also can be addressed. Then, so this was a part of that project here in this project. So where we are working. So it was actually, so although I have put it in a few slides, so it took long hours because we had to keep many tasks was the experiment to get the data, completely simulation based work. So analysis, signal processing, which is related to this part. So this part is related to the data analysis earlier. This one. And this one is analysis of that data. And then finding or proposing this index or this analysis. But then we need to validate it. So how to validate it? So again, statistical methods. So finding the correlations with the events or the phenomena. Or the differentiating capability with mix of these two states. So that need to be validated statistically. And once that statistical validation is done, so this is statistical data analysis, this one. Then we went for developing the hardware. So after developing the hardware, we also need to validate that because we have a little bit changed these formulations and we will be suitable for the hardware. Then we need to also find that whether this is the output of that is precise and correct with the events. And then as we are targeting the embedded system or portable system, so we also need to think of that less resource usage. Okay? Not only less resource usage, if we do not have a source of power except battery, then we also need to think of the power consumption. So it should be low power consumptions. And one of the ways to reduce the power consumption is to develop an architecture or algorithm which will require less number of activities. Okay? So like for example in embedded systems or advanced processors, we can find that day by day the clock frequency has been increased. Right? But is it always possible to increase the clock frequency without limit? Or even if, say, if I want to run some certain system in gigahertz level, can I do it with a battery? So point is no. So I need to have a continuous power supply. Otherwise, this battery will be drained very quickly. So then I cannot artificially increase the clock frequency of the system. Then the question comes that whether I can do it with reduced clock frequency or not. Then one option is that if I reduce the clock frequency, then I have to multiply the processing. That means number of processing must be increased. Okay? So then whole task divided into sub-tasks, and sub-tasks which are decoupled, not connected or dependent, they can run on concurrent basis or parallel basis time. So then each processor can run with slower clock, but it will ultimately fulfill the real time. And by what real time we mean, that which is executing its work within an affordable time limit. Now, what is this affordable time limit? So, how it is decided? So, I generally give two examples. One is, say, on the power line. When there is a fault, then we need to respond or treat the device within, say, microsecond orders. So, that means if I develop a physical system to operate this, then my physical system must run within 1 second of the event occurrence of the event. But there are certain systems like, say, predictions of the wave, which is very complex and requires a long execution time as long as, say, 1 day. But it is predicting for, say, 3 days again of this weather. So then 2 days there is a gap. So if I know the predictions 2 days prior to that, that also be usable. So that means this real-time constraint is actually given by the user, not by the system, right? And this is not dependent on the magnitude of the time. So even if something is taking 1 day time, it can be a real-time system, because it is depending on the utility of the system, right? So very often we have misconceptions that real-time means it should be very fast, but that is not true. Okay. So all these issues must be thought during the design of embedded system.
So in parallel processing, you are using less current or you are reducing a bit. Means if you are knowing the clock rate, then using parallel processes, I think the power is consumed. Less, the benefit is of the heat product. Is it true or actually consumes less power?
Actually, the concept is that paralleling time I am reducing the activities. Okay. Now you apply in your everyday life. Okay. In 1 day, you want to do, say, 20 tasks. Or in 1 day, you want to do 10 tasks. So which one will consume more power or energy? Basically, energy, total accumulation. So which will be used? So if you go for lower number of tasks, okay. Now, what is your clock? Your partners. Right? Your partners. That is clock. Simple enough. When you are speaking, what is your partner? And when you are running, what would be the partner? So more power, more energy, more clock wins. So you are basically increasing your number of activity per the time when you are running. So number of wins are increasing. So you need more power in every second. Right? So that's how this concept is. Okay.
In our country. I was there having a successful product. You have a volume spray. Volume spray is the brand name, the company name only, but that is the milk power. Milk power. In 1970, CSI developed this technology that transferred to this own company, and that is very popularized this product. So people are telling not milk power, like sauce. We're not telling a data like sauce. Okay, that is brand name. So these are our products. Means our job is to develop technology. Then we will transfer to some company. They will produce. This is a Suraj tractor. Sonalika tractor you have about Sonalika tractor. That is our product, our technology. CLRA Durgapur developed this technology. Then two-seater Hansa, this aircraft, civil aircraft for training purposes. Was National Aerospace Laboratory in Bangalore developed. Earlier I was working there 3 years for real-time simulation that the National Aerospace Department spread winter. Any missile or any satellite PSLV, MSLV, that thing will be tested out and winter. Real-time simulation will do. Then another product, this is the SALS. DK Rasi was the same. Who developed civil aircraft, 17-seater, 19-seater, first civil aircraft developed NDL Bangalore. National Aerospace Laboratory, Bangalore. Then you had about missile, the fighter, LCA, the fighter that is developed by ADA, Aeronautic Development Agency. But we had a lot of contributed. Like we have given 13 critical components for Tejas and also MC. And had hydrogen fuel cell was developed by National Chemical Laboratory, Pune. This is the hydrogen fuel cell was. This is the parallel processing component that is called flow server. Then developed in National Laboratory, Bangalore. And we know about this very fund given the board in general election that is developed by our CSR laboratories in 1952. So finally, also developed by CSR. Also, one diabetes medicine that is BGG is 36 or something that is developed by also CSR. Not all technology were only I sold able to reach to product. So you can find in our website, CSR website, means you are in the base product. Okay. So now we come to mineral materials. So major source of iron ores. Our Odisha is full of iron ore. You can see this mines, photograph, whatever. So now I am thinking why this person is building this showing mines in that. I am telling, I am creating one problem. Then I will give you solution. When you are electrical, mechanical, or electronic, you should have also domain knowledge. Means you are working in the area of health, you should have some medical knowledge, health knowledge. You are working aerospace, you should have also aerospace knowledge. In spite of your electrical knowledge. And like that, mineral material, this is the source of ores, different mines. We are getting a lot of roads and outdoor also. This is the photograph of mineral processing industries, very active, very dirty environment, hazardous environment. Everybody is preferred to wear aerospace, very good, but here very active. And how we are producing iron? Our blast furnace. We are putting some iron ores, then oak, limestone, and we will maintain some temperature like 40 degrees or something. Then there is wetting and producing molten iron. That is we call pig iron. Okay, that molten iron is called pig iron. Then whatever input this we will call slag. Okay. For now, we are not getting pure iron ores, we are getting low grade iron ores. Government of India decided iron ore having 45% iron content is considered throw. The center of money and the sale they will throw. If that ores is not having more iron content, they will throw somewhere. But government police, you have to utilize. How to utilize? You can direct sand to platforms because you get lot of slack, means lot of impurities. For removing the impurities is very difficult. So what they are doing, they are now they are grinding, they are taking over, they are grinding, then they are separating iron powders from impurities in physical method, then mineral processing on it. Then they are charging to platforms. Even if they cannot charge directly the lines to platforms because air cannot move from bottom to top. So they are making one circular object that is called pellet. Okay. This is a photograph pellet. This is fine iron fines. This is a rotating this fine. The production is pellet. Okay. Now this pellet, and instead of iron ore, they are putting this pellet inside the blast furnace and the coke limestone. Then they are getting the molten iron, pig iron. So this is the mineral processing department or engineering. Their job is like this: grinding, then combination of particle size, reduction of particle size. They will take the big boulders from mines. They will grind by grinder, then boil it. Then they will do separation, sizing or separation of particle size by different techniques: screening, classification, and rapid separation, hydrocyclone, spiral, stick. Then mineral processing software. We should not go to the details. We'll see what is the problem. We want to know the problem from issue. We want to give solution as the electrical engineer. Okay. This is the closing of their process. Here, this is a grinding wheel. This looks like very small, but a very bigger one in industry. They put all the nodes inside the wheel that rotate. Then they reduce the size from maybe 1 feet to 1 1 2 mm like that. So here the problem is this the grinding wheel consumes a lot of electrical energy. How to optimize, how to reduce the electrical energy. Also, during grinding, we don't know what is happening inside. What is the material, what is the particle size, how do you know? This is a problem. Now you people give the solution. You are engineer, whether electrical or electronics, instruments or any engineer. So you will have, this is our problem. They are facing problem. In our facing people that are facing problem, you have to know what is the particle size inside of grinding. Okay. What is the level of material? So how to know there is no sensor, there is not any sensor not available to such type of measurement. So you can develop. This is a research area. Okay, I will discuss this like in the house you are using grinding dinner. Okay, so can you measure that thickness of the taste? Whether this will become very good pair or little bigger one or more, you cannot measure. Just by your experience, you are thinking, okay, I will put 2 minutes, 1 minute, 3 minutes, then that will grind. So for that we need some sensor. Here, this is a higher side. This is a device to separate low density and high density material from solid. There are 2 pipes. One pipe will flow low density and the second pipe will flow high density material. So here what is happening, sometimes there becomes choke. How to measure the choke? That is another issue. You can see how to measure the choke. Okay, choking. Okay. Like your pipeline is going, then the leakage. In pipeline, then the leakage. Your water pipeline or oil pipeline. So how to measure that leakage? That is another issue. Okay. Here, this is also separating medium. Here are also same things. But here what is happening? there is some liquid and some flow in bubbles. So they want to measure the level of the liquid. The flow is there above the liquid, water flow is there. How to measure? Okay, that is also another challenge. This is the magnetic separator is used to separate magnetic material and non-magnetic material. Okay, and this is the challenge. So, can you use AI techniques to support finger processing? Yes, we can use for above problems like monitoring of the print mechanism, classification of the powers, and the soft sensing where no sensor is available. Sometimes the sensor is available, where the sensor is not available, we should develop soft sensor. What is soft sensor? Using a software. Okay. Using some another techniques, another sensor, we will develop one sensor. That is called soft sensor. Using software and AI techniques, okay, and some different type of principle. Okay, you can develop soft sensor. So now we come to topic. Here I was there, but the parallelism is the process of making balls, the circular object, a sphere from ice, water, and matter. And this is rotating the sphere, and the threading iron fines, water, and that is ball. That is called parallelism. Here the issue is that they are that parallel size 8 to 16 mm. Less than 8 mm, more than 16 mm is a position. So how to measure this parallel size? Can you measure how to measure in dynamic systems? Pellets are falling. You can see lot of pellets are falling. Use pellets are falling. How to measure the pellet size in online? So I can measure. I will give one ball. How to measure a ball diameter from 1 year caliber? From 1 year caliber. There is no sensor, no electrical sensor. But here we have to measure diameter of each and every pellet. Pellet is spherical or not. Vertical, I have to measure by 1 year caliber, mechanical sensor.
Then apply for a certain amount of magnetic field. If the size is larger, then it will fall.
No, all the magnetic. All the magnetic. I don't pure air, 100% air. Because what you are doing, we are grinding. Was separating impurities and was extracting only iron fines. Then iron fines I cannot charge directly to blast furnace because air can go from bottom to top. There is the blast furnace efficiency will be decreased. So that's why they need a particular size, 8 to 16 mm. Okay, less than 8, more than 16 also rejected. So how to measure? That is the issue. That is the problem for us. Because this is the problem, we have to give solution. Okay, we have to give a solution. That is possible. Okay. So now, how they are measuring? In India, we are having capacity, AMNS, okay, research name, swimming. As you can do swimming, what is that? They are doing swimming now. That is manual, that is also still mechanical method. Swimming also mechanical method. Okay. So, how they are doing it? Okay. We compare our system with the automatic company system. You can see this is a important system. The green color is detected palette. And how this is white color. We are able to detect each and every palette, maximum palettes. So where is the error? Where is the get? Our there. There because they are taking 2 samples. We're taking almost all samples. Okay. So our system is more accurate and less expensive. And due to our product,
modeling and instrumentation department of State and Scientific
okay,
Materials Technology. Balashore presents the ion pellet technology, an industrial product in support of Made in India. Iron ore mines are converted to spherical pellets using pelletization technology. The interest in pelletization technology is growing to meet the future demand of steel and steel products. Pelletization uses these pelletizers to produce spherical pellets. This pelletization process does not ensure production of equal size range pellets continuously. Therefore, on-site operators are engaged to continuously watch the disk and provide feedback to control room operators. This results in suboptimal performance of the disk, leading to reduced production and increased recycling load. CSIR Institute of Minerals and Materials Technology, Balashore, India, has developed an instrument named as BioPellet for real-time monitoring of growth of pellets in a pelletization plant. The system captures the image and disk discharge and generates the size distribution trend in real time. The size distribution trend clearly indicates the increasing and decreasing pellet growth. This information is useful for autonomy. The team is awarded with NI Engineering Impact Award 2014. This technology is transferred to SVNT Infotech Private Limited, Hyderabad for commercialization. This system is also field trial at many industries in India and also adopted by a leading steel plant of India. Seven numbers of the system is adopted by JSW Steel Limited, Nagpur, India, for its pellet plant 1. In addition to this, an automatic control system for iron ore disk pelletizer is also developed, which is named as Expert Ion Pellet.
So this is the only monitoring system. So only monitoring that is not sufficient. We have to also control. So how to develop control system? Simple PID control can be developed because the remote system multiple input multiple output very complex process. So now in India, operator controlling. Maybe less production, but they are controlling. So we propose an export control system, like export is hand-in-hand controlling. We have taken their inputs, how they are controlling. Then we have used the AICTE. We developed export control systems. So there are depends this speed, feed rate of material, and binder proportion, moisture content, and water content of material, and developing depressor, etc. Now, how they are controlling from manual? One operator standing, he is calling to control to change the RPM, change the TPS, then control will change. So everything is manual. Then we have to implement Industry 4.0. Okay. There is no operator. In the place of operator, we have inside camera. Okay. The camera is connected to control of fiber optics. The control distance is maybe 2 kilometers of fiber or 1 kilometer. We are connected to fiber optics. Then we are taking the size of the information from ion pellet that is into station hours, less than 8 hours, greater than the station hours. Then our export system are taking the signal like from nanometer from their land and dispatch system, distributed control system, and TPS, and moisture content from OPC communication, open ground communication, that is through land. Okay, we are taking information from the land DCS, and we are taking information from IOL, that is an IV information. Then we are deciding whether now size is decreasing, whether we will change the admin, whether we want to change the TPS, or whether we want to change the working point. So we are taking the decisions. That is the export system using AI and we'll suppose size is decreasing, then we'll give the some instruction to DCS system. Now we'll increase the RP, maybe increase RP more, or they may appear more. Like that, instruction we are giving to DCS. Automatically, that will give the PLC. Okay. Then PLC will give the signal to actuator whatever. Then not only speed accordingly. Like that, we are controlling. Same thing, whatever export is doing, we have trained our model. So that is running purposes. So this is another project. Model system also we got from DSC. Same improvement program is sponsored. This is the semi-automatic control using export device. Engineers and novel algorithms we are using. And we are controlling only RPM and TPS. Only two. My work is saving. Here only one fast project we are controlling only RPM and TPS. Not auto. And also we transfer this technology to Srinix company. Before transfer, we got an order to give one equipment. Okay. Then he required to manufacture this type of product. Then I am taking risk also manufactured. Then he has taken this technology. There is been project in 2021. This was schematic of inductor sector. How we are doing? This is pellets are falling, but image is connected to ion pellet monitoring systems. Then this is the control system export ion pellet. This is DCS, plant DCS. From plant DCS, we are taking RPM, TPS, bentonite, and moisture. And this control is giving the signal to DCS. DCS is giving the signal to PLC, and PLC is controlling the RPM, TPS. This is the schematic diagram of inductor sector. This is the GUI of export ion pellet system. You can see here. Now, oversize, careful, oversize, this AI generation algorithm we have done. So you can control RPM and TPS. So features, you have a right connectivity with the central DCS. Main thing is the connects DCS, our system is very difficult. There is OPC, which is the old system, our language system, OPC UA, to interface is very difficult. So that thing also, that was very challenging to integrate. So here are the problems. So as an engineer, we should see problem. Where the issue? The problem is sometimes what is happening here due to material, then material will come at a disadvantage. So we will get measurement. And that's overlapping of pellets. Pellets is overlapping. And sometimes here you can see lot of dots during how to measure. There was an image. Sometimes you will measure. Light is changing. all are dynamic systems. How to do image processing? That is the issue. That's the problem of chemical research. I'm going to do and our publishing paper also and that area. So here the machine learning based image processing. Whether it be ANN, CNN, object detection, everything nowadays. People are using camera based systems. You can see visual perception. You will go to doctor is seeing the X-ray. You can also do automatic instead of doctor. Our camera based system can be okay. Everything now image processing based system. Some already people I think that driver is there using also. Okay. So machine learning based image processing for item or pellet size analysis. We have published, we have one of 5 patents book, and then I also 23 and 24. We are having 2 patents in this area. You can see here how we are doing machine learning based image processing for item or analysis. We are making images. And I program evaluation. Then we are moving through a CNN model. This paper can be here, but the size is very small, or good, big, and very big. We have published this paper in good journal. We are actively inducting application. Very good journal. Actively inducting application. Another is publishing river computing and applications. So another one we have done online monitoring of iron and pellet size with distribution using live CNN. So the previous one was oscilloscope. So can measure oscilloscope. The previous one which you were showing that was an oscilloscope. Not oscilloscope. I am generating one signal one. Okay. Already connected 9 into 1. So here I put one data and sort of here. Just I put drag and drop. Then already this has come. Aqua signals. Want to aqua signal. Generate. Want to control. Then generate signal. Want to aqua. Then aqua. Just click in aqua signal. Here as the. Then whether the signal is analog or digital, you have to choose. My signal is analog. Analog input. Then whether the signal is voltage, temperature, strain, current, resistance, automatically I can solve. Okay. But I know my signal is temperature. Then I click on temperature. Then there is a lot of temperature. RTD, connector, thermocouple, which one I have connected. I know I have connected thermocouple. So I will select thermocouple. Then automatically the software detected which hardware is connected. The hardware is connected. Okay. That is not connected. That is some similar thing with that is fine. Apart from that, I have to consider. I am not connected. What are the story that is similar stories? I will remove this problem. Yes, sir. But this hardware is not connected to the PC. I am not connected to the USB. They are automatically connected. Then I have to share this thing. Then right click, rhythm diagram, diagram, back aspect, then aqua signal, another input, temperature, thermocouple. Then your software detected change. Okay, this is whatever the user that was showing simulation, tag device. Simulated tag device is inside. Okay. Now, speed that in mode 1, 9205, 9211. 9 to 1 is this one, hard one. Okay, the 9 to 1. Okay, that is temperature pad. Thermocouple. 9 to 05, 5 days away. 9 to 05 is the other input pad, voltage pad. With thermocouple is the voltage, that's the diagram. Two pad is, but 9 to 05 is not okay. Okay, but I have to select thermocouple pad, then 9 to 11. And here we see that mod 4. Mod 4 means your slot number 4. From here it is counting 1, 2, 3, 4. Then the 1 that is 9 to 05. Here 1, 9 to 05 is there. And you are able to know. Okay, easily you are able to know. Then I have connected my thermocouple like AI0. Physically, I am connected AI0. You can't go number. Finish. Then, what to measure temperature? Whether thermocouple J type, K type, you have to select. Here you can say different type of thermocouple. J, K, N, R, S, T, G, E. So, I do my thermocouple J type. So I will select J type. Okay. So your temperature range, how much temperature range you want to measure? Maybe this room temperature is around 45 to 30 degrees centigrade. So my range should be 0 to 100. If I put 0 to 1000, then you will get some measurement. Okay. Always you will put your range, whatever range you want to measure, and that range your 0 to 100. And my unit is degree centigrade. Then I have to acquire continuous node. Continuous samples to read 3 hours. Temperature sampling rate is very slow. 2 hours. Okay, this is not a dynamic state. The vibration in kilohertz. Then just building reality. Whatever I have good company I am building, right taking. Then it is telling, can you put auto loop? I am not putting auto loop. No. Okay. I am not putting auto loop. I will create graph indicator. What of graph indicator is that? Okay. Then wrong. Some temperature 24 degree. Okay. And now this is not continuous. For continuous, I am put while loop. Okay. Here I will put while loop. Structure over while loop, just drag and drop. Code condition create and control. Okay. Now if I run this one, there is wrong continuously. The program is continuous. Okay, just I will put this and temperature is increasing. Okay, I have seen indicator how much temperature. Tightly create indicator. Numeric indicator. Okay. Size represent color blue quality. Inside the black. Temperature is 24.99. Okay, 24.95. I'm just holding this up. By increasing temperature. Okay, this is my body temperature. Okay. Exactly. Okay, this data I have to write. I have to write the top here, right click, express by go output, then method type, but write is not as maybe sending slide, get top, sending minutes. I write temperature. 10. Okay. Okay. Then last will connect here. Connected. Here, there is nothing there, nothing there. 10 is nothing, not available. But result are running. You can see the log in the program. I can check. See, 30 degrees. There, 30 degrees. Here I will put some logic. More than 49, my every will grow. But here I have to put on the like this, memory color, thermometer will go. Right, okay, good job. Then I will put on logic. And now we will go. Put that now. What's the that is more than 49. Sir, coming here. Okay. Then I'm increasing the temperature. Right. Increasing. After 29, I will yes. Then something like this. Everything will be there. Yes, now temperature is 28 degrees, but I put 49. I come. When I was like that, usually when developers they some connectable from our phone, no, little bit programming, but usually but you will see that they are something. Like that, we can acquire also. Can acquire Bible. Bible, like that. Here I will connect on a vibration sensor here on vibration sensor. Then active signal. Another input. Then I will connect to vibration. Okay. When the vibration is passive, okay. Just to click. Then I have connected IP type to sensor. Then this is showing NI 904. Then 3 slot. This is the slot 3. Okay. X, Y, Z, I am putting 3 input. So I will select AI0, AI1, AI2. Finish. Then my input range is -5 volt to 5 volt. Unit is G, sensitivity 1000. N sample I will put quantical sample. I have to acquire continuously. Then my sampling ready. 25.6 kilohertz sampling rate. Okay. Then you want to put a while loop. There's while loop there. And right click. Create the graph indicator. Okay. I am running the program. Because you can measure. Okay, because I have 100 here. This one plate, so I have to highlight this one. Inside this I have to do. So this first side.
The force vibration.
No, not false vibration.
Force. Not force.
So why this week three? I have connected 3 X, Y, 5 X, 7. X, Y, Z. You can check here. X, Y, Z. Try X, not even X. That's the X, Y, Z. You want to enter the rows simple
It may happen that one of the student may be studious, but as they grow, we will assume that these are the mischievous students. Similarly, here is also the scenario. We have to find out k number of nearest neighbors. These nearest neighbors machines have status is known to us. Then we have to assume. We have to take the majority voting. We have to ask whether these are true or false. After taking the majority voting, we will come out with the conclusion. Okay? Now let us try how to move this problem. So you can see it here. Here we have assumed that our K is equal to 3. Usually, in the K nearest neighborhood, your K will be assumed as a odd number. Can anyone tell me why or?
Within number, tell me what. Half is there, half is there.
Correct. Say, if I will take K equals to 4, 4 number of nearest neighbor. Huh? 2 nearest neighbor are telling that my machine is faulty. 2 nearest neighbor machines, they are telling that my machine is non.
50-50.
Then 50-50 probability is there that it is yes or it is no. So what decision we will take? We have to avoid such scenarios. We are taking odd number. So 2, 3 over if K equals to 5, then 2, 3. So some probability will be low and some probability will be high. That's why K equals to odd number. So let us start with here. We have started with K equals to 3. That means for each of the instances, I want to check this machine ID X4 that is having vibration level 3, temperature 37 and humidity 68. That I have to compare with each of the samples present in the test. And I am simply writing step. Take for example, in our class we have 60 students. In the 60 students, we have some categories according to the CGPA. Excellent, good, average, bad. So 4 category students are there. One new student has taken that answer. Then we will assign that new student to which group? We have to find out first that new student is having CGPA how much? Is having attendance how much? What is the extra skill that particular student is having? What is the previous record, previous college record, what is about his conduct? Everything we have to analyze, and the student having maximum similarity to the group, we can assign that student that well. This is the normal scenario. Here also the same way. What we will do for that particular unknown machines, we will find out the distance of this unknown machines to the known machines. Okay? Then we have to find out what are the top 3 closest machines. Clear? So from that top 3 closest machines, 2 closest machines, what is the majority of the machines are telling? Top 3 closest machines, from the top 3 closest machines, 2 machines are telling that these are faulty. That means, whatever the machines we are talking about, that is also faulty. That is the scenario in the KNN. So in order to find out the distance of that unknown machine to the known machines, we have to find out some mathematical formulas to find out how similar my unknown data is to the known data. I have to find out the distance. In order to find out the distance, you know different types of distance measures are there. Your N1 distance, N2 distance, right? Manhattan distance, city block distance, different types of distance are there, Euclidean distance. So what you have to do? Why will you go for an Euclidean distance and or your Manhattan distance or N1 and N2, whatever is known? Because whatever the data here is, these are numerical. Temperature, humidity, your vibration level, these are numerical. So when we are talking about the numerical data, we will find out the distance using a N1 or N2 mark. If it is not a numerical data, it is a categorical data, then we will go for a cosine similarity. There are different measures. But when we are talking about the structured data, numerical structured data, we can utilize N1 or N2 mark. Clear enough? Okay. So now what is my task? My task is to, from this vibration level, temperature level and humidity level, I have to find out the distance of this unknown sample to the known sample. Okay. Say for an example, I am computing this distance with the first one. What is the distance? The distance is x1 minus x1 bar square plus x2 minus x2 bar square plus x3 minus x3 bar square. So what is x1? x1 is 3, x2 is 37, x3 is 68. What is x1 bar?
Mean of average.
No. This is not x1 bar, this is x1 dash.
Yes, sure.
x1 dash means the first sample. You can see it here. What is the first sample?
Right.
2. Vibration is 2, temperature is 35, and your humidity is 60. So now what we are doing? We are measuring the distance of this sample to the unknown sample. Okay? What is the formula? The formula is x1 minus x1 dash square plus x2 minus x2 dash square plus x3 minus x2 dash square. Clear? So we have find out some distance. See here. So when I am having 5 machines, I am having here 5 machines. So for 5 machines, I am having 5 distances. This is the only machine. I am having more 5 machines. So I am having distance 2 from this machine, distance 3 from this machine, distance 4 from this machine, distance 1 from this machine. Then what I have to do? I have to sort that distance. So say closest also machine here. Okay, so closest machine, how many closest machines I will take? I will take 3 numbers of closest machines. Why? Because I have chosen k is equal to 3. Clear, sir? Sir?
I have X dash.
X dash is the original number, original data.
First will be
Then data is equal to 97.0 with temperature 35 degrees. So how can I do this?
This is X dash. You just have a look.
X1
X1 dash, what is X1 dash? X1 dash is the vibration of the first one. What is X2 dash? Temperature of the first one. What is X3 dash? Humidity of the first one. What is X1, X2, X3? X1, X2, X3 are the vibration level, temperature and humidity of the unknown gases. So each time you will get a value. When you compute D of A, distance of A, you will get one value for first sample. You will get another value for second sample, you will get another value for third sample, fourth sample, fifth sample. So 5 distances I am getting. Now what I am doing, I am sorting that distances. Which machine is closer to my original machine? So you can have a look. Distance, one is 3.2, 3.64, 8.31, 10.6 is 14.8. These are 5 distances. And top 3 machines are valued closer machines to this original, to this original machines. Am I clear or having any ambiguity? You are getting confused?
Madam, previous problem at the point of previous problem belongs to various right? This is like this. How we can classify it?
Yeah. While how this calculated question is, if a machine is having temperature this, vibration this, humidity this, then the machine is a healthy machine or a faulty machine. You find out whether it is a healthy machine or a faulty machine. That means what is your question? The question is to find out the level of the machine. The machine is a good machine or a faulty machine. In the regression, what was it? How many power consumption it has done? So regression is telling you the value. What is the power consumption? This much kilowatt hour. But here, instead of a value, you are providing even level, whether faulty or not. That's why it is a classification.
classifying the machine.
Binary classification. Okay? Say for an example, instead of 2, if it is faulty, critically faulty, then not faulty. Then it is a multi-class classification. Clear? Okay. So now what I have done, I am just summarizing the thing. Unknown data sample is given to me. I have to find out the distance of this unknown machine to the known machines. How I will find out by utilizing L1 norm or L2 norm. Here I will use L2 norm. Once I will find out the distance, I will sort all this distance. So the topmost 3 project sample I will select. Here, out of this 5, I will select machine number 5, machine number 3, machine number 1. Why? Because these machines are having lower distance to the unknown machines. One is 3.2, one is 3.64, another one is 8.31. Am I clear? Okay. Now, question arises, how to assign the level of the unknown sample? We have to take the majority voting. Out of these 3 project samples, what are their stats? Out of this, machine 5 is telling it is healthy. You can have a look. Machine 5 status is healthy. Can you see that?
Yes.
Machine 3 status is faulty. Machine 2 status is healthy. That means what is the majority? Machine 5 is healthy, machine 3 is faulty, machine 1 is healthy. Then majority of the machines close to that unknown machines are telling that they are healthy. That means that based upon the majority voting, we are assigning that the new unknown machine is also healthy. Clear everyone? Anyone having any doubt? See, here I have taken very small ones. Only 5 samples are there. But in real time, you will be having thousands number of samples. And also each one is will be represented by n number of features. Here we are having only 5 samples. Each sample is represented by only 3 features. That's why I can show you this expression. X1 minus X1 back. This is the mathematics behind your KNN. This how does it work. But how to do it in the real time? Are you going to calculate the distance of each individual from 100 number or 1000 number of samples? No. What you have to do is, as I have told you, the scalar linear model, you can import models. Directly model is there. Import KNN. So KNN again. Once you import this KNN algorithm, you can feed this model. Feed its training. You are training the model. During the training process, you are getting these parameters, distance measure and everything, or K equals to 3. During testing, you are assigning this with the majority voting point. Clear? Whatever I have shown you mathematically, these things are already coded by the Python libraries. These Python libraries are already inbuilt. I am talking about Google Colab. Google Colab is all of you. I would suggest all of you, those who have not yet started your work, you can start this very easily. Google Colab is a cloud environment where we libraries, Pandas, NumPy, Scalar, all these are machine learning libraries. Once you import it, see, technology has developed like anything. And libraries are already there. No need to do your programming from scratch. I am not telling you to write down the program to write down this, to upload this mathematical program. Already it's there. So what you need to do? Only you need to do is you can import this. You can import that library, write down your program, feed the model. I am telling the model.fit. Model.fit will do all this mathematics. After model.fit, you will write a model.predict. Model.predict means it will test. It will give you a result that it is belonging to class 0, class 1. Clear everyone? So this was my point. Where I bifurcated to this, I have told that in the research methodology, once your research problem, domain problem is fixed, then your aim is fixed, objective is fixed. In order to find out, in order to exhibit one objective, you have to collect the data. Data collection is there, then you have to go for the data processing. Data pre-processing is done means you have to go for the analysis like this, regression or classification algorithm. From that analysis, you are interpreting the results that this machine is faulty or this machine is healthy. After interpreting the results, you are recommending some solutions. So these are the entire process. Clear everyone? So research methodology में भी यही करते हैं हम लोग ना. Result हो गया, analysis हो गया, interpretation हो गया. Now the question is conclusion. We are talking about writing down the conclusion. Okay, what to write down the conclusion? So how much time I have? I will continue this session up to 1. 150. Okay, time. So what to write down in the conclusion?
We interpret the data and give the analysis.
ये तो interpretation और analysis तो हो गया, result का analysis section में.
मैडम क्या भी लिख सकते हैं कंक्लूजन?
कंक्लूजन में क्या लिखेंगे? क्या तो लिख चुके हैं,
कंक्लूजन ये कर देते हैं. अगर ये
Comparison में further scope क्या होता है? What we have done in the total, that will like in the conclusion.
No, not me. See, I will tell you, it is very important. Whenever you people are writing down any conference paper, any journal paper, any newspaper, anything, what is your, I will show you a paper how to write down. But still I am telling you that conclusion is restate your aim. What you started your writing from the aim, problem statement aim, restate your aim. We have started analyzing the mental health of working women due to the mobile exam. This is your aim. After that, what conclusion, what implications you are getting out of that? A person who is having 6 hours of mobile addiction may be getting affected with stress and anxiety. This is your implications. Further, if you will not take care of this stress, this may hamper the productivity at your workplace or your professional life. And what is my point of telling conclusion is that first point is reset your aim. What findings you have got in terms of quantitative parameters. Quantitative parameters means हम लोग ये नहीं बोल सकते हैं कि the women or the working women, those who are spending lots of time in the mobile phone, they will get anxiety. Lots of it is HC1. You have to write down the quantitative parameter. What is that quantitative parameter? 6 hours, 10 hours, like that. Or say 20, apart from that, you can write 15 to 20% working women, those who are addicting to this, into these 6 hours or 7 hours, they have the probability of 70% attack to the stress level. So these types of findings, no diameter conclusion. Followed by what is the applications, where you can apply these things, scalability of that product, what. It is not only like that you are going to analyze this impact in the working women of your academics. You can just further scale it for your IT sectors. You can further scale it for your service sectors, healthcare, or you can go for any other applications. And the last one will be more interesting. Clear everyone? Clear? So step back from problem to conclusion. Is it done from the result methodology or something else is missing? Something else is missing. The important part is missing. Can you mention?
So BERT is an encoder. Okay, so in transformer, you have two. Okay, you have two things, two components. One is encoder, the other one is decoder. So encoder only models are BERT. Decoder only models are GPT. Okay, generative preprint transformer. So you get, so you have input sentence, CLS. Any idea about CLS? This is a class token which is being added to classify. For example, if you want to classify anything, then you have that CLS token. So CLS token can be used to classify the sentence, can be used to classify the document, it can be used for anything. Okay. So BERT is mainly used for classification. So BERT training, so how will you do that? So you have transformer encoder, okay. So CLS is your classified token. Then you have a mask. So you have a mask. So now the transformer encoder model has to predict what is the fill in the blank. What is the fill in the blank? So I am llamas or anything. I love llamas. I am llamas or anything. I love llamas. Anything can come. So in training on large data set, so all these models are trained on internet data. Okay, so the common data set is C4 data set. C4 data set. Okay, so C4 data set. It's available. You can read about how the transformer models are trained on internet data. Okay, then this data is been given to BERT. So you have done the pre-training. So it has got the general intelligence. Okay, so it is like you have read a lot, and then you want to fine-tune for downstream tasks. Okay, so BERT can be used for classification, it can be used for name entity recognition or characterized identification. All these things can be done with BERT. Okay, so GPTs are also good in classification. They are very good in zero shot learning, few shot learning, or single shot learning, all these things. Okay. Generative models. Okay, so these are decoder only models. So I love it has to predict the next token, llamas. So these are self-supervised. Any idea about supervised, unsupervised?
supervised, unsupervised techniques. So, for example, supervised means if you have an image and for that image you have a label. Label is available to you. You feed both image and the label to the model and you train the model. That is supervised. Unsupervised means you don't have any label. So, for example, clustering is unsupervised technique. If you use k-means clustering or any kind of clustering algorithm is unsupervised. GPT is self-supervised. Self-supervised means internet has lots of data. So whatever data which is available in the internet can be used for training. So how will you train the model? So it has to predict the next word. It has to predict the next word. That's it. So I love llamas. So I love. Then it has to predict the llamas. It can be anything. I love going to school. I love cinema. I love anything. Anything can come. Okay. So this is self-supervised. You don't need any labeling data. It has to just predict the next word. Okay. Any questions on this? So these are generative pre-trained transformers. Okay, GPT. All GPTs are decoder only models. Okay. So if we see GPT models, we started with 117 million parameters, 1.5 billion parameters, 175 billion parameters, and nobody knows what is there in GPT 3.5, which is ChatGPT, and then GPT 4.0, after that GPT 4.0 mini, 4.0, 4.0 reasoning. So many models has come. So out of these GPT-1, GPT-2, GPT-3, which one will be good? Any idea? Which one will be good? GPT-1, 2 or 3? Why 3? Huh? It's a large language model, but why? So you have GPT-1, GPT-2, then you have GPT-3. So GPT-3, you see the number of parameters, okay? 117, 1.5 billion, and this is close to 175 times. And so you can just take off the kind of parameter which may have gone into GPT-4, which is currently running in ChatGPT. Okay. So the reason why GPT-3 is more powerful because it has more number of parameters. So if you have more number of parameters, so it can learn a lot. Right? Okay. So it has weights. Okay. So weights. So if you have more number of parameters, so that means more number of weights. More number of weights means it can learn a lot better than this GPT-1, GPT-2. Okay. But if you have a big powerful model, but if you don't have the data set to train, then you will go into the problem of underfitting. Okay, so underfitting happens when, for example, you have a big powerful model, but you don't have the data. So the underfitting happens. If you have a smaller model, then what will happen if you have a small model and data set, if you have, what do you call it? So this is the problem of underfitting. So this is where overfitting will happen. Overfitting means it has, for example, it has learn, it has by heart everything, but if you give it something new, it may not be able to means it may not be able to predict, it may not be able to generalize. So the problem of if you don't have data, if you keep on increasing the model size, so that will eventually lead to underfitting. But if you have a smaller model and if you just check with that low many number of then you have this overfitting happening. Okay. So this is the context length which I was talking about. Context length is something which I have spoken about. For example, what is the input and what is the output. So every word is being fed into the model. For example, tell me something about llamas. Llamas are domesticated. So tell me something about llamas. Llamas are domesticated. So once domesticated is generated, this will come here. It will be filled into the model, and then it has to predict the next token. What will be the next word? Okay. So this is how. This is why I was talking. I was telling you about. For example, if you have a book which is of some 1,000 pages, and if you feed that book into your ChatGPT and if you ask ChatGPT to summarize the book, then the problem of this context length be very small, just because all
Yes, sir. Now just you said I went to the ChatGPT and I said write a poem on seed. Yes, complete seed. So it's bringing the poem which was written by a poet. It's not writing any poem.
okay, so SEED. Okay, so what
I think one on seed written by a poet long ago.
Okay, so I'll come to that part.
Seed is generating complete and
Okay, I'll come to that part. So what happens is very interesting question. So GPT is trained on internet data. It's trained on internet data. It has seen what no one else has seen. Okay, so it has seen all the data which is available in the internet. Okay, and it has to predict the next token. So what happens is in GPT, 99% of the data is you have the pre-training model. Pre-training means so 99% it has been pre-trained on internet data. I'll come to your question. Before that, let me give you a context. Okay. So, for example, if you
another thing also I want to add. In the university last year, so there is a plugin software with the company personalized now and it was demonstrating.
Yes.
Then I told him, you tell a line, I mean the same thing in a different way. And there is no plagiarism.
Yes. So I
it failed the plagiarism test.
Okay. I'll come to that.
Things are yes. In the plagiarism test while we are submitting. While we are submitting our PhD, it can analyze the statistical matter. Means if you are the case, whether you got it from somewhere else or something like that.
Okay, so that is something which is limited. I will say that is something limited to the plagiarism software. Okay, so if somebody is using data, if somebody is using LLMs, powerful LLMs, then it should be able to tell what is the plagiarism. Okay. The plagiarism can be from your university book, it can be from cases, so that I will come. But if the plagiarism software is not using any LLMs or any agentic, for example, 3 plus 2, if you type in 3 plus 2 is 5. So for doing this, what LLM will do? LLM will pull in Python, okay, and it will just type in 3 plus 2. But 3 plus 2 is very common. So it knows 5 will come. Just because it has seen lot of data. 3 plus 2 is equal to 5, written in so many books or so many things. But 3 into something to the power or something to the power will be, means the ChatGPT will fail here. So what ChatGPT will do, 3 into something very big number. So what ChatGPT will do, ChatGPT will pull an external tool like Python, it will type it and it will fetch that number. And then that number will be displayed to you. So ChatGPT, they have thoughtfully, they have thought about it, how the answer should be, which should be more creative. It should not be nonsensical. It should be, it should make sense. It should have some information, and along with that, some kind of thing. And I'll come to that point, how they do it. Okay. Okay. So this will be too much, I think, for you guys. If I go into transformers, so if you want, I can go. But generally what happens is you can do parallel processing. Okay, you can do parallel processing in transformer models. So how this parallel processing happens? So write an email apologizing to Sarah for the tragic gardening mishap. Explain how it happened. So before transformer, there was a model known as RMM or LSTM model. So it will go sequentially. Okay. So when you feed in sequentially, it has to wait. It has to wait for everything, and then it will have some context. After that, it will start writing something. So this parallel token processing has made sure that you make use of the GPU for compute and as well as trading is faster. Okay, so how they do it? All these, write an email, first tokenization, then embedding, then all these, tokenization has happened. Tokenization will feed into the transformer block, and all data will go at a time. It will not depend on writing then an email apologizing to Sarah for the tragic gardening mishap. It will not happen sequentially, it will happen parallelly. So that is why we are able to do the computation faster and they are able to train it more effectively. Okay. So they have this caching of keys and values very much. Okay. So this is how the transformer. Okay. You have inside the transformer block. So you have this tokenizer. Okay. Tokenizer, what it will do? Then tokenizer will divide the words into tokens, divide the sentence into tokenizer. Then it will give you some embedding. Embedding will go into transformer block. Inside the transformer block, you have self-attention and you have feed-forward neural net. Okay, so feed-forward, you may have read about neural networks. So before CNN, feed-forward neural network was there. So basically, if you want to classify something, if you want to predict something, then you have this feed-forward neural network. But here it is self-attention. Okay, self-attention. For example, let me show you. Okay, this one, the attention layer. The dog chased the squirrel because here, if a human reads, he can make use of the word it. It can understand. Means a human will be able to understand and it will be able to correlate it with what? Which word? The dog chased the squirrel because because it can even say. So, what exactly? What is it referring to? No, what others are referring to. So the dog, you have the dog chased the squirrel because it carries information. Okay, it has some information. So it has to it should get the context, and how that context will be. The context will be coming from self-attention. So basically, you do a dot product between it with every other word, and it tries to find out what is the similarity. Okay, what is the similarity of it with dog? What is the similarity of it with chase? What is the similarity of it with the squirrel? Because so some kind of dot product. So when you do a dot product, you get some similarity score. So with the similarity score, so it will be related to which word?
Yes.
So first thing is the dog chased the squirrel because it was too tired, or because it was on the road, or because it was on the garden, anything. But it has to be correlated with which word. So that's what. The dog chased the squirrel because it was too tired, or it was on the garden, or it was on the tree, anything. So does it make sense? So all this is happening in this self-attention. Okay, so I'll not go into more detail. So all these informations are all brands. If you're interested, I can explain. Okay, so let's see how this classification happens. So you have classification using language model. So you have this representation language model, and you have this generative language model. So representation is encoder kind of model, and generative language model is your decoder kind of model, which is GPT. Okay, so you have the input, you have the LLM, and then the best category for the text. So it has to classify. So input, so it has some classes 0, 1, 2, and has come up with 1. But in case of generative, sir, as I was saying, generative pre-trained transformer, it has to generate something. What it will generate? Classification prompt containing the input text. Classification, it has to do classification. Classification prompt containing the input text. This is the input which will feed into the model. The input class is of the type 1. 1 means returns. So that has been generated by the GPT model. 1 means return. Return is the classifier. Okay, return is a classification. So this, how a non-exhaustive list. So you can specify that you have to answer in 2 lines. As these are text completion model, so it will try to complete. Otherwise, as it has been trained to predict the next word, it will try to predict unless until it doesn't get the end of sentence. Okay, end of sentence token. If it doesn't get, then it will try to predict. It will just keep on predicting. But that data may not be helpful to you. But what you can do is you can be more precise. Just like it's in your exam, if somebody has written 5 pages, but if someone has written 2 pages, or 2 pages or maybe 1 page, but the context is there, what the question has asked. So you will be giving more marks. So like that, write a description for a product in less than 2 sentences. So this is the specificity, that means user has provided that you should provide within this two sentences. Hallucination, okay. To reduce its impact, for example, if LLM doesn't know, it will try to hallucinate. So what you can do is, if it does not know, say I don't. Okay, if you hallucinate means, for example, if you ask something which LLM has not seen using many data, it will try to hallucinate. It will try to come up with some answer, random answer, which may not be helpful to you. Okay, so that is hallucination. Okay, and then order. How you specify? For example, LLMs are very good. Something which is coming in the beginning or something which is coming in the end. Something which is in the middle, it tries to forget. Okay, so that is also you can do. This is what I was talking about, persona. Okay, so you can specify persona. So, for example, if you want LLMs to give marks to BTech students, then you can specify that you assume that you are a teacher, BTech first year, and you have to give marks. So, instruction, you can give instruction. If somebody has written this, you have to give 1 mark. If somebody has written this, you have to give 1 mark. Then context, we can also give a context. What is the context? What should be the format? If somebody has written some bullet points, then you have to give something marks, like that. And audience, who is the audience? Format should be, who is the audience? Audience is you BTech first year, like that. Tone, how should the tone be? For example, it should be professional, or it should be polite, or it should be, means for example, funny, or something like that. Data for this can be taken care of. Okay, iterating the prompts. So, prompt engineering, I was talking about, you have to write some prompt, you have to iterate, you add or remove, and then you just keep on playing with the words such that you get a better outcome. Okay. So, chain of thoughts, this is very popular nowadays. So, in prompt engineering, so chain of thoughts means one thought leading to another thought, then that thought leading to another thought. So, you are making the LLMs to think. You think before you answer. So, one answer leading to the second answer, second answer leading to the third answer. That's how you make the model to think and answer. Okay, so for example, if you take Viva of a student and the student says something, you're not happy, so then you give him some time. Give him some time, take your time, answer this in interview also. You take some time and answer. So then you start giving some hints. So question this, hint this. So now he will again question this, hint this. So he will start thinking. He will start solving the puzzle. Okay. First generated product name, then this is given to this chain of thoughts. That's how you're making the true learn. Okay. So this is the book which I have followed. If you want to read more about it, this is the very good book. Okay, hands-on large language model, correlate publication, and this book is available in the internet. It's also available in Amazon. If you want to read, it's a very good. Okay,
So it's Jay.
Jay Ala Mamal. Something I'm also not sure how to pronounce it, but whatever I have taught you is from this book. Okay, and with my experience working with the LLMs. But all the slides are from this book. Okay, so if you have any questions, I'm happy to hear. You can go runtime and change runtime. So here you can specify. So you have in order to run this machine learning code, you need some CUDA. So without CUDA, it's just like your if you want to do some computation, so CUDA is very good. CUDA is from NVIDIA and that you can use it. Okay, so you need CUDA. If CUDA is not available, then it will run CPU.
CUDA.
So CUDA is basically some matrix multiplication. So that matrix multiplication, how that matrix multiplication will be done. So all these ML models, they do only matrix multiplication. How good? No, so basically, our college guidelines you claim only limited data. So that limited data means the matrix is very small. But here you're talking about the data size is very high, and when you have, for example, 1024 cross 124 matrix, those kind of configuration are will be very slow. So in order to do that, they have this kernel which is optimized to do this matrix multiplication. And that matrix multiplication can be done in GPU. So that if you don't have a GPU, then you will be going back to CPU. Okay, so this is how it is. Then the output is you are selecting the R max. You see what is the negative score, what is the positive score. So you have the data set. You are trying to get the test set. So in machine learning, you have train, validation, and test. Okay, so basically we train on training data set and we test on the test data set. So that's all it is. So assignment. So you are trying to get the R max, which is the max value.
So machine learning is mostly using object-oriented.
Yes, you are writing mostly class, class and objects, so all these things you will do. So there will be people use Python for writing this. Okay, and then you can go for this one. What is your classification matrix? So classification matrix will tell you where are you going wrong, whether you have more of true positive or more of false positive or more of false negative. So based on that, you can change your label data, or you can change the model and see is the output changing or not. Okay, now we have a sentence transformer. This is a supervised classification. It is using another model, sentence transformer, and from that we have selected NPNet base model. Okay, you have selected the training embedding and you have got the test embedding as well. Okay, training embedding size is this. Okay, so that means it has this many tokens and 768 is the embedding vector dimension. 768. Okay, and then you call logistic regression any classifier. So if you run it, then that will give you some probability, and that probability can be used to classify. Okay. And again, you can go over this classification matrix. Okay, so this is, then again, if you want zero shot. So I was talking about zero shot. So you have label embeddings, you have negative review, a positive review, and try to find out the cosine similarity, and that's how you find out what is the precision for negative review, what is the precision for positive review, like that. You can. So all these things are available. Okay. And this is one more encoder decoder model. So I have not gone into the encoder decoder model, how encoder decoder works. So this is one more T5 model, which is encoder decoder model. You can also use ChatGPT. Okay. So this is what I was talking about. So you have to call ChatGPT OpenAI app. So they will ask for API key. So you should have access to those. You have to give the API key, then only you can call ChatGPT. Okay, and you have to specify system. So persona, you are a helpful assistant. So you have to find the persona, role, content, like that. Here you can specify temperature is equal to 2. That means you are selecting only the highest probability. Okay, so this is how it is. So this is this was one of the applications of ChatGPT.
I'm going to discuss like what I'm going to do, how it is working. What I'm trying to discuss is what the different important component common picture. Right? So the next thing is the like the actual algorithm. Like nowadays we're talking about ChatGPT and all, right? We use the like other people are using Google. Nowadays I think no one is using Google. Every people get information. You go to ChatGPT and ask, it will give a very fine answer, right? So, and what it is doing, because it has huge data to train AI model, right? And it can infer, and it can find some conclusion from those data. Okay, so one part is data, another part is the AI model. So all the AI engineers, what they are doing, they are designing a very a model, a very efficient model in which they can put some data, take some decision, right? And in this picture, there is one more another important thing, that is the computer in which they are running this algorithm, right? So let's take an example. Like I have a very good configuration computer from Intel processor. So we will start with a very basic example. I wanted to run some data, some algorithm, maybe some LLM algorithm. I have some algorithm. I don't know inside the algorithm. I know there is an algorithm that is better, and I wanted to train some model. So to train that model, I use, for example, Python. So that is the popular programming language nowadays it is using. And there is a model already there, so I have to give this information to the model. I have a data set to put it, and I train it. Finally, train this model, what I observed that for certain algorithm, it is very too much time. It is taking overnight. So people think people are working in AI must be. So the one of the important problem is time. So maybe some model to train, it takes overnight, it takes hours. It might take some week also. Okay, why? Why? The reason is, so end of the day, any computer model, any ML model will run in a computer. Okay, so in order to understand this, I wanted to go to the basic architecture of a computer. Right? Let's understand a little bit. So it is not directly relevant, but let's understand how a computer works. Okay. So whenever I'm talking a computer, right, it's not like a conventional computer or laptop. It is a computing device. My mobile is a computer, smartwatch is a computer. Even like a refrigerator, right? So smart refrigerator, it has a small computer into it. Okay, so any computing device is considered as a computer, and what it has? It actually has three basic units. Okay, any computer we talk about, it has three basic units. One is processor, one is memory, and communication unit. Okay, so that is the concept of computer. It's a long back, like the history is 1946. There is a computer science on Newman. So he gave this concept, and nowadays every computing device we are using, either it is a computer or a laptop or a smartwatch, right, or a small device, for example, your pen drive. This is also a single computer. It's a computer because it has a computing device like a chip processor, it has a memory, and there is a communication that is on some other protocol in the data and instruction, right? Okay, so this is the main thing. So let's talk about our own problem, like in diagram, like every model is not able to run the computer, and I'm trying to run this computer. So I just keep few things. I wanted to show a small program. Okay, so if you are not much familiar in C, it's okay. So what this C program is doing, you have a big array, okay, and two array, for example, you want to add it, okay. So this small program, what you will do, you will add this to array and store this information in third array, okay. This is implemented in C. You can implement it in any language, doesn't matter. The basic logic is same. So the basic logic what I told, right? The processor, memory, communication, how it works is all the same. There is no change. What I'm trying to show is, so there is a loop basically. And why am I using this loop? because I have a huge data. So in AI/ML algorithm, if you see internally, all the data is stored in terms of metrics, a two-dimensional, multi-dimensional basically. To make it simple, I'm showing it in a single dimensional data, like array is a single dimensional data. I can make it with data two-dimensional, three-dimensional, four-dimensional, multi-dimensional data. In fact, in AI/ML it will be multi-dimensional data. So whenever it is being processed, for example, in this case I'm doing addition, right? So whenever I'm doing addition, I have 10, for example, here it is 5. You assume that it might have a billion for size, for example. And this loop will run for billion iteration, right? Every first element will run, the second element, third element, right? So it will keep on adding and storing the third variable. Okay. But why I'm showing it, I'm trying to explain the problem. Okay. If your instruction is very less, doesn't matter, it's fine because many software has been running in this computer without any problem. It is pretty much good. But whenever I'm talking about AI/ML model, it is not that case because in case of the AI/ML model, very low, right? So that involved is very huge, right? So we have a like I just told, right? To model a complex model, you might need thousands of lakhs of input, many more intermediate layer, and the data is also multiple dimensions. So when we do it, it takes huge time. In order to make it simple, what I'm trying to tell is, whatever the algorithm you do for a computer, all this algorithm will finally converted into either a matrix multiplication or a sum of matrix multiplication. So there are basically two operations happens in most of the algorithm. Many other operations also done, but that is the most complex operation has been done. And if you are not from computer background, it's fine. But if you are from computer background, if I have two matrices of same dimension, for example 100 by 100 both matrices, and I want to multiply, what is the order to multiply? It will be order of what? To multiply two matrices. So to multiply, okay, for the multiplication, let's start with the addition. If you want to add two-dimensional matrix, what is the order? Order means how much time it is taking, right? In terms of size. So in this example, if you say it is 5 iteration, this loop is going 5 iteration because size is 5, because array size is 5. If the array size is 100, it will take 100 iterations. That means order is n. If this A and B is two-dimensional, the order will be n square. That means if both the size is 5, so total time will be 5 into 5 to 25. Because if you want to convert it into a program, right? So that will be two columns, right? Because you have rows and columns. We have to move each row. Suppose there is 4 by 4. First row 5 iteration, second 5, third 5, fourth 5. That is very simple because there is a 5 by 5. Think about the area of lakhs dimension. Or same thing, maybe array size is 100. It's fine. But I am doing this thousands of times. Addition is 1,000 times. Multiplication is 1,000 times. So addition complexity is order of n square. Multiplication is order of n cube. That means if two matrix size is 100, so 100 raised to 3. That is the complexity. And if you think like I have lakhs of dimensions, and this is not a single one multiplexer. How can I multiplexer? There is a problem now, right? Because that point of time this computer might not help, right? So that's what I'm coming to the GPU and AI accelerator, right? That's why the conventional computer might not good enough for AI algorithm. So what I'm trying to tell is the initial, right? Program management. So whatever I saw the simple C program is sequential. Why it is like that? Because my program runs sequentially. So whenever I want to add dimensional array, I have to go sequentially. Like first index to element I add, then second index, then third index, then fourth index. And in the same case, I have a powerful computer and many more code. in which to adding this two element, I will give to one processor, another two element I will give to another processor, another two element I will give to another processor. Then it will be faster, right? So I don't want to go back in this things. What I'm trying to tell is, the conventional computer is sequential in nature. It takes a lot of time. If I want to make it faster, I have to change the model from sequential to parallel. Just give a simple example. Like there are thousands of people standing in a queue, and you have to distribute something to them. Okay, so one guy will start distributing something, and to distribute to one guy it takes 1 second. 1,000 people it will take 1,000 seconds. Simple. So what you do? When next same thing you have to do, but you do little differently. You created two row, right? One row 500 people, another row 500 people. You involve two people to distribute now. So two people started distributing. Now first time will take 500 seconds, right? Because at the same time you are doing the same thing, but with two help of two people. Now maybe in the third day, what you do the same thing with the help of 4 people. So create 4 rows, right? And each row you involve 100 people. So now it will take 1 by 4, right? So that's the basic concept of any GPU and all. Okay, so that is called parallel programming. So there is a train is a basically scientist, computer scientist. He gave an architecture like how this program is running our system. So he gave 4 models: single instruction, single data, single instruction, multiple data, then multiple instruction, single data, multiple instruction, multiple data. So in our interest, we will not discuss the third and fourth, we discuss only first and second. So in our previous example, whatever I show you is single instruction, single data. I have an array, 1,000, the array size is 1,000. So if I want to add this to array, every time I have to pick. And we are talking about only 64 It is not even comparable, right? So to make it parallel, our computer cannot be utilized. I cannot use this computer because our computer mainly is specific for general purpose sequential program. Because it can be used for many things, right? So I cannot make this parallel program in my computer. Okay. So now the question is, who can solve this problem? So the obvious answer is I can give this information to an external guy, right? My computer cannot do. So what I do, I will ask someone who can do this, okay? And that someone is basically the GPU, okay? GPU or AI accelerator. And we will talk about it. So what this GPU will do? So this thing, so what this GPU AI accelerator basically called core processor. So what do you mean by core processor? So in the computer, the main processor is the CPU processor. Okay, that is the main computer. And there are many more processors they can work along with this. So let me give you a very familiar example which you know. My pen drive, my hard drive, my SSD drive. So all these are actually core processor. But why am I saying it is core processor? So in the pen drive itself, there is a very small chip. There is a memory, there is instruction, it is also working. Why am I using that? Because it is used to store the data along with my computer, and the purpose of the data is to store the data. So how it is storing the data is also this pen drive or hard drive. That's why it has their own processor, it will store it own way. That's why there is a processor. Okay. So in our program, in order to give a if you want to get a optimized result from your AI application, so I can use those agents. Those agents is available like GPU or AI accelerator. So let's start with GPU, graphical processing unit. So what is the graphical processing unit? So before AI will come into picture, right? So graphical processor unit is also not new. It has been used since long time. Okay, we know that. And maybe those people who are more passionate about gaming, they can tell better, right? Because if you are a person for gaming who are the gaming computer who has very good graphics, because I have to play some game. and I know that if there is a gaming is required, then CPU will be the main problem, right? If it has CPU, then it will be good. Isn't it? We know that, right? Why it is like that? Okay. First of all, GPU is not helping only for AI application, it can help many other applications. Let's talk about, you are talking about gaming or this video rendering and image processing, right? So all this GPU is used. Because if you see that, all this problem, the data is in matrix. So take example of image processing and also image related things. So all this data will be taken to same photo, right? The photo can be represented in a two-dimensional array, right? And each pixel can be represented as RGB, right? RGB means red, green, blue. There are many representations just out of RGB format. So that means an image can be represented as a multi-dimensional array of data. So my computer doesn't understand a analog image. So if you process an image, so it will be converted into some multi-dimensional matrix. That's all. And there will be some value. So maybe from 0 to 255, 0 to 255, the pixel value basically. So for the computer, it is just a number matrix with some value. Doesn't matter anything, right? And when I am trying to process anything, so now the data is matrix. Now the obvious answer you understand why we are talking about parallel processor. Will I give an example, right? In this example, I know that whenever a matrix involves matrix multiplication, matrix addition, sequential program will not have. So it is a special program of parallel computing, and GPU is obvious answer. So now at least we understand that CPU works in a sequential fashion and GPU works in parallel fashion. So now tell me how, I don't know one example, right? In which I said the CPU has 32 core, right? It can be maximum core 34 to 64. Can you tell me how many core a CPU can have? Maybe estimate, only the correct thing. Any answer? How many core process core it will have? It can have this.
I think 4050 and 2650 both. Could cores.
2650, okay.
Approx 2650, okay. And I'm very good at 4050.
Okay. Okay. 2056 you said. 2048 for example.
Yes.
So can you compare? Its GPU typically has thousands of cores, right? And the CPU has only 2 digit core, maximum 2 digit core. And that's the difference. Okay. And this picture, right? It will tell you like how say this is representing one core, which is processing the text one another. The same example if you reconnect, right? There is a matrix of some dimension, maybe 100 dimension, now we can say 100 dimension. And if you want to do any multiplication or addition, then parallelly all this can be drawn in each and every core. You give addition for like if a matrix, it can be divided into 0, 0, 0, 1, 0, 2, 1, 0, 1, 2, 1, 2 like that, right? So if it is 100 into 100, then that means 10 raised to 4. That means that many individual threads I can be created and give to one thread in GPU and they can run it. So to make it parallel. Okay, so that are many applications and this is the obvious difference. The CPU will be very few cores, GPU has thousands of cores, and the CPU will mainly used for the serial tasks and GPU is for parallel. So now we'll discuss about the GPU. GPU is similar to CPU but it has thousands of cores, it runs on parallel, right? Then what is AI accelerator, right? So before that I just got one thing, video. So GPU is not only used for AI, it is used for video processing, it is used for image processing, it is used for gaming, it is a very general purpose, right? But AI accelerator is being only for AI related things. AI related things just to train the model. So you can say GPU is also an AI accelerator. So GPU, AI accelerator is very specific, GPU is a very general. Okay. So GPU can be used for anything. So nowadays GPU you must be heard about the NVIDIA GPU, right? So all are talking about that. And the most important thing, like NVIDIA is going high because earlier people are not able to use GPU for any other purpose except this video processing, image processing and all. But now they can use GPU in AML to train the model to be pretty better performance. And that's why their stock going high and company is going high. Okay.
NVIDIA quantum can AICTE does. NVIDIA quantum.
So let me clarify. So that is a GPU.
Yes.
So the difference between GPU and AI is very small difference. Okay. So initially it was used for a generic purpose. But few of the companies who realize that GPU is very generic, right? So if you think of the data center of Google, in the Google data center, there are a lot of only AML model is running. There is no need of video processing, no need of gaming and all that. So there is not much improvement in, like, there is some improvement. They wanted to improve little more. That's why they start with AI accelerator, and which is mainly only for AML model. Okay, to train AML model. And this is the use case, like that's what so you think of autonomous vehicle. So huge data is generated in autonomous vehicle that is a more some of the model. So that there is no video processing, no like gaming and all. Only those cases in which the huge data will be trained by the model will be mainly for the AML purpose. That's why the AI accelerator is being used. But this GPU is a core processor, as I said, right? So it will be intelligently connected to the CPU, right? So to the like there is a external GPU card, external device I connect to my system and it will help. So how will be connecting? Any external device can be connected to some protocol, right? So like PCI, right? For example. So earlier we must be about SATA, PATA, or SSD hard drive was there. That times those protocols were used. But now every other device is using actually PCI device. So this GPU is basically connected to PCI nowadays. But in the data center and all, right? So even PCI bandwidth is not good enough. So there are many other protocol components. So there are something called Thunderbolt. So NVIDIA has its own protocol. Okay, it will internally use PCI, but it has its own protocol. Okay, so all the GPU devices is connected to the CPU through the I/O bus. Okay, in a computer, and the basic principle is any program you do. So, for example, I am running a GPU model. Let me come with the example just to make it a little better understanding. So, I am not going to explain this. So, this is a Python code which is used for image classification. This is normal Python code which is used for image classification. So, if you are using Python channel, right? So, in Python you install Python, you install Python. And I will write this program. This program will pretty much run on your computer without any problem. Okay, maybe time if you don't have GPU, it will take longer time. And if you have CPU, it will take less time. So now let's think about it. So how, when I am running this in my computer, how does it matter? How I am sending this information to GPU and all, right? So any AML algorithm that are two principles. Okay. The very first principle is the base code. This is called base code. Will run on the host system. Host system is the CPU system, and only few things, few computation, which is very expensive, will go to GPU. Okay, so that means only few things will go to GPU, and which are the things? What are those things? Which are listed, right? Matrix multiplication, matrix addition, all the matrix computation will go to GPU. So there is a way to send this information to the CPU. Okay, and what are this way? Will come just a second. So, okay, let's say this principle. So I have a matrix to add, and I wrote this software like Python. I write the code. Now this code running in my computer. That means this my computer has its own RAM or memory. this instruction is loaded into the memory, the data is loaded into the memory, think about the matrix data, right? So now I want to send this data into the GPU. So that's why I need some utility function to transfer this data. Okay, so the very first utility function to copy the data from CPU to GPU, then do the computation in the GPU, then write back the data from transfer the data from GPU to CPU. This is the basic principle of either it is GPU or an accelerator or anything. Okay, so the main algorithm will run on your computer. Only few instructions will go to CPU, and what are the instructions or computation intensive is instruction, right? Like matrix multiplication, matrix addition, okay? And okay, I have not discussed about CUDA, so I will just introduce CUDA. So we are talking about only invention. So in market there are many GPUs are available. Now you think, yeah, so what are the other GPUs?
Radeon and Intel.
Radeon is
easy,
right?
and Intel is now trying to make.
Correct. So if you think about this GPU, right, this is external, right? My computer is based on Intel, and I am running Python into it, right? There is a Python. So how my Python will be able to know that hey, there is a GPU connected, if it is a NVIDIA GPU, or it is a AMD GPU, or it is a Intel GPU. So there is a software compatibility between them. So there is another open standard which is called OpenCL. So OpenCL is a common program, open standard program is started for parallel programming. Okay. So similar to OpenCL, there is a CUDA program. So CUDA is basically a programming paradigm given by NVIDIA, and this program is basically for NVIDIA GPU. What I'm trying to tell is my computer and NVIDIA is totally different. So that's what we are understanding between these two, right? There should be some standard. My computer should know that, suppose my computer is able to understand that there is a NVIDIA GPU connected. But how can I send the information to this guy? So that is the interface, right? So CUDA is the interface. So CUDA will provide those interface API to communicate. So what is this API? This is discuss. I have to send data. So I need the API. So NVIDIA will provide the API to either, like if you want to transfer the data, you use this API. If you want to send the data back from CPU to CPU, you use this API, right? And this API will be discussing maybe in some few of the slide. This is the slide, right? So first of all, if you want to allocate some memory in the device, so there is something called CUDA memory. And you want to copy from the whole device, there is a CUDA copy. So CUDA copy is a function, right? And there is an attribute field in which you can mention either you want to transfer the data from memory to both to device or device to person. Okay. So CUDA is basically a normal, you can say it's a framework, and it's a communication between your both system, both software system and the external device. Okay. And CUDA is specifically by NVIDIA. Now I want to.
It is proprietary.
It is proprietary to NVIDIA. That's why I asked, right? Why I asked other GPU, like suppose you have AMD GPU, and
It is open.
it will be used OpenCL, because in using OpenCL, you can run NVIDIA GPU, you can run like AMD, you can run Intel, everything. Okay, but you see, right? Nowadays 90% of GPU market is given by NVIDIA. So CUDA is very famous. So in my slide, most of the thing is CUDA based. Okay, so before going to explain, I wanted to tell you one more thing about this, how these things work. So I told if I compare to matrix and all, right? I got thousands of table work. So that is a principle. So okay, let me give another example. This there is a GPU which has 1024 thread, for example, okay, here is 1024 thread. Now I have a matrix which has dimension, suppose 10,000 into 1000, for example. So whenever I wanted to convert this, so the number of threads will be more than 1024. So I can run one parallel thing, right? That's why there is a concept of block. Okay. So what we do, we create a small block in which maybe the block size will be 4 by 4 for example. That means 16, dimension is 16. So I can create a block of dimension 16 and this 16 dimension will be representing a group of threads, right? And this can be known as parallel, right? You got my point, right? Why I am doing this? Because in order to manage the number of threads in my actual GPU and the number of actual threads in the problem. Because problem is not GPU specific.
There will be no overlapping. Like if you are taking a single geometry and you take a block of suppose 2 by 2.
Okay.
Then while you are
No, this is fixed. See, this specification will be from the GPU side. So the GPU has a fixed like this is the block side. The entire thing is called grid.
yeah.
So one will be represented by one thread. So in a block, if a block is 4 by 4, that means total 16 different threads is there, right? So assume that this grid is 1024. For example, the total size is 1024 number of threads, but a block size is 16. So that means 16 independent threads can run on parallel. So this can run, this can run, this can run. So that the advantage is, whatever the problem side it is, it can be broken into small pieces and that can run on parallel. Okay. Okay, so one of the important things of this technique of memory, I will not discuss more about it because it is very much specific to the memory technology. Okay, so the basic paradigm of any programming, instruction will be written into memory. These instructions will go to the processor, it will be drawn and come back. Either it is CPU or GPU doesn't matter, same thing happens. But if you take about the same problem, what I will discuss, there is a matrix multiplication. And then all the instructions that are present in the memory, instruction also present in the memory, and we bring matrix multiplication. If you think about the individual instruction running on parallel, there is an intuitive result. So give an example of matrix multiplication, right? So if there is a matrix multiplication A, so the column row 1 into column 1, second is row 2 into column 2. So this is how if you multiply so matrix row and second matrix column, right? So you have to do like this. So that is a temporary information will come. So how does it regarding to forget to memory? It will come and go from and all, right? So we have not come right now, as of now, but it will come. And this is probably good for the GPU that will use now. Okay. Now, TensorFlow, I will go. TensorFlow is basically a few million stuff. So TensorFlow is an AI accelerator. Okay. So it is not similar to GPU. The way it is probably very different. Okay. In GPU, all the work will be on a parallel ways, but in case of TensorFlow, it is somewhere it is parallel, but it is really different. I just wanted to tell you how it is different. So, see, there is some data present. So, all this data will be loaded into the system memory. There is a high speed memory. Okay. And all in this memory, in this data, it will go to all this code. Now, again, come back to the code. Then keep on running inside the all this memory, like intermediate result, right? I was telling about the intermediate result. It is going back to memory in the GPU. So here it is not going back to the GPU. Inside the CPU itself, this intermediate result will be stored, and final data will come from final data will go to the output. So that is very different. So that is the concept of AI accelerator. The concept is called systolic array. Systolic array is basically, so this is the example subject you will know, right? So we have to multiply the units. So that is sum of multiplication, right? So you first you count them, second to them, third to them. So you have to keep this result, right? So in GPU we are storing this sum temporary result in the memory. But here you are not storing the memory, you are storing inside the chip itself, right? So that is called systolic array. So this technique will make the it's more faster, right? Because when you're talking about freedom or billion of this parameter, right? If it is 1 to 100, doesn't matter whether you are in the processor or memory. But whenever this parameter is in million really have to, then the performance matters. So that's the key difference from GPU to AI accelerator. So this is one of the concerns. In Intel accelerator, the concept is a little different. Okay, so I was expressing about GPUs, I will discuss like systematic array concept. It will be a processing the data. And as I told, right, earlier the GPU was not using HBM, high bandwidth memory, but AI accelerator is starting using HBM only because it has to process huge amount of data, so it is always used HBM. And the interconnect is always from PCI. So from PCI also AI accelerator will be connected to the computer. Yeah, basically use case like energy, computer, visa. So all this, because all these things are related things. So everything can be a use case to use your AI accelerator. And if you have anything also, okay. So one of the important things again I mentioned by discussing GPU also. So there are basically two things, right? So they are training the model and you are testing the model or using the model basically, not testing. So using the model is called inference, right? So suppose the model is ready and you have to deploy somewhere. So when like the model is used, there is also some data happens, right? But inference is looking, let us say, computation and with respect of reality. But still, inference also we bring a GPU because that is still the requirement of comparison and all, right? So if you think about all this GPU, also initially it was very serious, explosive effect. It started with only inference, the inference and training, then all advanced. So now I think V6, V5 and V6 or V7 is already there. Okay, so it's much more advanced with this. So whenever it is in place, the basic concept is set. Only thing is like in the previous quantum, the speed, there will increase the speed, number of device supported. So those things that will change. Okay, but basic concept is set. I think
very difficult to find out a discrete data. Actually, very tough job. This is not an easy job. Like for example, if you are talking about tree diagram, then your class. This is your classifier. So this is your classifier. This classifier is representing this database. This is a small database, and this is very popular in data mining as well as pattern recognition. People are very much familiar with this. So if you have a database like this, then you can develop a tree with few branches and couple of nodes. You can represent the database very effectively. So this tree has been constructed from this past data, from this database. This tree has been constructed from this database itself. So this is known as very interesting algorithm that is known as ID3, iterative dichotomizer 3. Iterative dichotomizer. Dichotomizer means either binary, yes or no. Iterative dichotomizer 3. Or some variants of this are C4.5, many variants, CAT, so many variants are there. So this is one of the very popular classification algorithm. In machine learning, one of the very popular classification algorithm that is known as decision tree. Based on decision tree, you can classify the unknown sum. Okay, and this is a database. Of course, very simple database. You can very easily understand that age, income, student, credit rating, and this is a class. So this is also a two-class problem. Yes or no? If the student age is less than equal to 30, income is high, and studentship no, and credit rating is fair, then probably he or she belongs to class no. Like this, you have samples. How many samples? 14 samples. Based on these 14 samples, this tree has been constructed. So ID3, the kernel of ID3, the kernel of this decision tree is entropy. Okay, but do you know the entropy? What is an entropy? You can go. What is the mathematics behind this? Entropy. How do you use this?
High entropy means it will be unstable.
Okay. Then what is the value? Maximum value? Okay, some information theory, no? Entropy, information gain theory. That is information gain theory. Entropy can give you whether a particular attribute is very informative or not. Then how do you this? How do you do this? Like pi log pi. Entropy means minus pi log pi. Very simple. Minus pi log base to pi. This is known as entropy. Based on this entropy, you can effectively construct which attribute can be taken as root node. This is your root node. This is a tree. No, this is a tree diagram. This is a tree. So it has attributes like age, student, credit rating. So only 3 attributes. I mean, out of 4 attributes, predicting attributes. So this is class attribute. Okay. So you should not consider class attribute. You should consider these 4 attributes. Based on these 4 attributes, you need to construct. I mean, age is taken for root node, and student is taken for intermediate node. Credit rating is taken for another intermediate node. And then the last level nodes are yes or no. I mean class level. And the branches are representing the value of the attributes. Value of the attributes. Okay, the branches are representing value of the attributes. And based on the entropy measure, this tree has been constructed. So this is a very effective classifier. I am not going to discuss your algorithm because these are all available in standard book that you can easily get it. Then again, how the classification problem can be visualized through the line. I told you the line can be acted as the discriminator between 2 classes. Like for example, this data set has been taken from the machine learning repository. So one of the very popular database in machine learning community, that is known as IRIS database. You know that probably. That is UCI, University of California, Irvine. They have maintained their database repository. Okay. So from that repository, I have taken this IRIS. So it has 3 classes: Iris setosa. I mean, Iris is a kind of flower. How to develop a machine that can classify the flowers. 3 categories of flowers. 3 categories of flowers. You can also take sample from your nearby flower gardens, and you can also develop like this. So Iris setosa, Iris versicolor, and virginica. So 3 classes, and I have taken 2 attributes: petal width as well as petal length. Maybe other 4 attributes are also sepal length, sepal width are available. But I have taken, because 4 dimension I cannot plot, no, we cannot visualize. So therefore I have taken 2, or I can consider 3 attributes. So I have considered here 2 attributes. You see, there is a clear separation between setosa and versicolor. This line is enough. This line is enough. But you tell me, how many lines are possible between setosa and versicolor? Infinite. But you need to find out the optimal one. So this is a kind of optimization process. Understand? So this is a kind of, from visualization you can say, this is a kind of optimization problem. Similarly, versicolor and virginica, they are not well separated. So there is an overlap. Okay. Even if you are looking for an optimized, okay, a line which is on the basis of best optimization process, you want it. So you need to be satisfied with approximate solution. Otherwise, you won't get a solution in your life. Understand? So in this case, it is required to be satisfied with the approximate solution, and this is the best discriminatory. Okay, so this is the best discriminator for this. So this is a class and this is another class. So for 3 class problem, at least we need 2 lines. Okay, in this case, 2 lines.
There is something called principal component analysis.
Principal component analysis is a different thing that is known as feature selection. No, not feature selection, feature extraction. Sorry, feature extraction. Principal component analysis. Through principal component analysis, you can visualize the situation. How do you visualize the situation? That means we are limited with 2-3 dimensions. Okay? If the database has more than 3 dimensions, 10 dimensions, 10 attributes, then how do you do this? So you apply the principal component. Select relevant dimensions. Since you are limited with 3, then use principal component analysis, then visualize them. So that's why principal component is very, very useful. Principal component is primarily used for dimensionality reduction, not for classification. Dimensionality reduction, or you can say attribute extraction or feature extraction. So there, what is the formula of principal component analysis? Eigenvalues. If you know that trick, then you can easily get the principal components. Understand? So that is not my business. So let me focus with this. Again, the classification problem can also be visualized through rules, a set of rules. And this set of rules can be extracted from the decision tree, or you can by self you can generate these rules. Okay, and the rule are represented through. So ultimately, this is a kind of knowledge. If consequent, then antecedent. If consequent, then antecedent. So antecedent is having only one attribute in the case of classification problem. Antecedent is having only one attribute in the case of classification problem. So these are the consequent. So this is the consequent part. If antecedent, then consequent. So consequent has only one attribute, but antecedent has set of attributes. And this antecedent, the attributes which are involved in the antecedent, they are associated with an end condition, not or condition. Okay, end condition. Okay. So if antecedent, then consequent. If antecedent, then consequent. Consequent is having only one attribute, and that is known as in classification of class attributes. And this relation may be sometimes equal relation, or less than equal to relation, or maybe greater than or not equal. Rule can be represented as if then statement, not else. If then statement. If antecedent, I told you, if antecedent, then consequent. But antecedent, that means this is a function of attribute with operation along with values. And this is a end condition. Okay, this is an end condition. Okay, I told you end condition, not or condition. This is an end condition. Then operation can be taken from the domain like either equal to, I told you, less than equal to, or greater than equal to, or greater than, or simply less than, or not equal to. The antecedent number of attributes given just, and the consequent is having only one attribute with operation. Domain of the attributes may be continuous, or maybe discrete, or maybe mixed. The domain of the attribute may be continuous, or may be discrete, or may be mixed. Okay. So this is the story, but I told you I have just described one effective classifier, that is decision tree that can handle only discrete items, not continuous. The constraint of a decision tree algorithm is that can only handle discrete items. It cannot handle continuous items. So in order to handle continuous attribute through decision tree, then you have to convert a continuous to, you need to discretize the continuous database to a discrete database, then only you can use. While converting or while mapping from continuous to discrete, you may lose information that you need to take. Otherwise, you might get useless. But that may not be true. Okay. Then why this problem is very, very important? My concern is that why this problem is very, very important, as well as how complex this problem, why we need the multi-objective optimization, I mean theory of multi-objective optimization, or maybe a kind of machine learning algorithm, like meta-heuristic algorithms. You see, let the attribute be discrete. For example, we have a database with discrete, and we have a database with discrete attributes. And let we have n number of attributes, excluding the class 1. Excluding the class 1, we have n number of attributes. Then each attribute contains, for example, 2 discrete values. Then how many number of rules we can generate? How many number of rules we can generate? Then so we can tell. We have how many attributes? N attributes. We have n attributes, excluding the class attribute. And each attribute is containing only 2 discrete values, or in general, k discrete values. In general, k discrete values. Then how many rules are possible? Exhaustive. How many rules exhaustively we can generate? Exhaustively.
The 2 to the power n.
2 to the power k. Or 2 to the power n. 2 to the power n is 2. 2 to the power n. Or I told him in general. So what is the number of exhaustive number of rules?
K is
K to the power n. Because k into k into k into how many times? N times. Similarly, 2 into 2 into 2 into how many times? N times. So 2 to the power n. K to the power n. Etc. So this is the number of rules. So if it is k to the power n, you see how big the surface. If it is 2 to the power n, then what we have to say in mathematics? This is exponential, no? This is exponential, no? 2 to the power n is 10 to the power. Yes, this is the same. I understand. This is sorry. This is map to a rule. Okay. This is a map to a rule. Similarly, how many rules? If we have nothing, how many rules we have? 6 rules. How many? Now you tell me, this is a very visual engineering visualize. How many minimum number of rules you can take so that we can cover all the points? So this is knowledge classification. How many minimum number of rules we can take so that we can cover minimum? I'm asking minimum number. You can take all of the rules for covering all the points. But that is useless. So what are those rules? S4, S5, S4, S3, S3, and S5. Any other possible solutions? Why? Okay, this is a very simple problem. So that's why. But while solving this kind of problem, you know, you need to minimize the overlap. So while considering rules, you need to minimize the overlap. And definitely to maximize the.
Can it K
Yes. K number of rules. You can include part of this. It is simple case. I think I have part of the total done for the what about you? They have that. But part of the best one, but what else? How many? In this case, one guy over these three rules. This is okay, but our objective is to maximize the coverage and minimize the overlap. Okay, minimize the overlap. So this is also a kind of interesting multi-objective optimization problem. So with this, I'm concluding the classification task of machine classification part of machine learning. Then let us have a look on regression, another problem. This is also a kind of predictive task and very popular with machine learning. Okay. So regression is nothing but a kind of establishment of functional relationship between more than two variables, but I am restricting myself with two variables, x and y. Okay. So x is known as independent variable and y is known as dependent variable. So either you are going to fit a line like this. So this can be like y equal to d1x, d1 is the slope, or maybe y equal to b0 plus b1x. Maybe like a simple line, y equal to m plus c. You know that m is the slope and c is the intercept like this. So this is a test. And y equal to b0 plus b1x plus b2x square. So this is a quadratic equation. Okay. So maybe a kind of polynomial here. So maybe if the data points are not linearly distributed, then it will get to find out the suitable polynomial for that to get the right analysis. Okay. So this is a kind of regression analysis. So there are so many types of regression analysis. Since I have just highlighted only linear regression, simple linear regression. So then how do you, if it is the case, then how do you do your business? Then how do you find out the value of b0 and b1? Let us talk about this. If it is a linear regression, then how do you find the coefficient?
They have been taken only and you go for the fitting. The labels of the movement is fitting. So you will solve the new equations.
No. Y equal to b0 plus b1x. So this is not a curve, this is a line. Okay, simple line. So it has slope is b1 and b0 is your intercept. Okay. Then how do you find out the value of b0 and b1? Through the past data. Past data is given to you, no? Based on the past data, you need to find out the value of b0 and b1 and predict for the future. Predict for the future. I mean, the moment I will give you, suppose you are given with n values like x1, y1, x2, y2, like this, xn, yn. Okay. Each one is having output. Okay. Now, if I will give you as n plus 1, what is the value of yn plus 1? How do you do this? Based on the n data points, you need to find out the value of b0 and b1. Least way of estimation method. So this is one of the very effective method. Yes. What is that? Least estimation method. So using that least square estimation method, you can effectively find out the value of b0 and b1, and then you can do your business. Similarly, so since life is not simple and life is not so simple, so very complex, no, the problem, the situation, every problem of the society is a very complex problem. So since it is complex, not linear problem, so it is a kind of non-linear problem. It is a kind of non-linear problem. So therefore, regression is not that simple. So we need a kind of non-linear kind of regression. So one of the popular non-linear regression problem is corner ridge regression. Corner ridge regression. Ridge regression, then corner ridge regression. Corners. No suitable corners for that. Corner ridge regression is very famous and very useful also in practical life. So that is all about the story of predictive data analysis under the umbrella of machine learning. Now, and they are coming under supervised learning. Now, we will discuss one of the unsupervised learning techniques that is known as cluster analysis. So, in cluster analysis, what happens? So, this is nowadays very useful for remote sensing. Images. You can analyze the remote sensing images. So, very effectively, you can analyze remotely sensed data. And so you see, the cluster analysis means, so this is also a kind of process. Okay. So clustering is a kind of process that you are going to reveal clusters or maybe groups on the underlying data. And the interesting part of this situation is that here each individual sample or entity or object is not associated with any cluster. Okay, they don't have cluster. So that's why it is known as unsupervised learning, because no supervisor is here. Okay, so on the
instances or the samples are not associated with any class level. So therefore, it is very difficult. This task is also a very complex task. Okay. So cluster analysis or clustering means to reveal groups or clusters on the underlying data through proximity measures. What are those proximity measures? For example, ingredient distance. You can consider as one of the suitable proximity measures to measure the closeness of two data points. So this is the complex part, and this is, you see, this is one cluster, and over and above there is another cluster. So this is a kind of very difficult, no? Very difficult set. It is very difficult set, and this is also not a simple problem. This is also very complex, but this is very simple. This is a very simple. You can easily get it by your classical algorithms like B-means, C-means, so many algorithms are developed. So maybe thousands of algorithms. This is also like looking very complex. So briefly we can say a good clustering. I'm giving emphasis on good clustering, not simply clustering. Good clustering method will produce high quality clusters with high intra-class similarity but low inter-class similarity. Inter-class similarity must be low, must be minimum. And intra-class within a class, within a group, they must be very close to each other, very near to each other. Okay, so these are the suitable packages you need to consider while discovering or while uncovering clusters of say given or online data. Understand? So even though it is looking simple or visualizing simple, but it is not that easy. So because when writing programs, we are facing lots of problems. The quality of a clustering result depends on both the similarity measure, what type of similarity measure you are using to find out the proximity between 2 points, and its suitable implementation. How we are implementing, how many parameters are associated with particular algorithm, which you are developed or which you are using. So these are the solutions. And if you will compare this solution with this, if you will compare, forget about this. If you will compare this solution with this, then what will happen? What will happen? You see, this solution, try to focus on it, because in next couple of slides you need to answer. You need to play your active role, AI role. This solution I am discarding from this picture. This solution I am discarding from this picture. Why? Can anybody tell?
Because it has more weight compared to protein.
Not only weight, then you need to consider both.
Yes, more weight compared to protein.
Yes. So this solution, if you are comparing this with this, this with this is neither better than with respect to weight, nor better than with respect to protein.
Yes.
Neither better than with respect to weight, nor better than with respect to protein. Therefore, these are verified from this list. So these are the no contribution. Okay. So this solution is known as dominated solution. In multi-objective optimization, we have a concept of dominance. Or sometimes we are saying Pareto solution. Pareto. Hill according to the name of the Pareto. Okay. So this solution is known as dominated solution, and this one is known as non-dominated solution. Okay. So this solution is dominating to this. Like this, if you will compare this with this, but if you will compare this with this, you cannot say this one is dominating to this. But if you will compare this with this, then again this is dominating to this. If one of the solution is dominating, that should be discarded from this. So all non-number, your objective is to
keep all the non-dominated solution and discard all the dominated solution. So this is the simple thing in multi-objective optimization. Your task is to uncover or find out all the dominated solutions and discard. The rest of the solutions are non-dominated solutions, and they are finally they are constituting your part of non-dominated solution. You see, and this one, these are the set of non-dominated solutions, and they are constituting part of. So, Pareto solution or Pareto. Pareto, this is also important. See, then types of multi-objective optimization. What are the types? Like either you can minimize all objectives, or you can maximize all objectives, or a few objectives you can minimize, and the rest you can maximize. Okay. So these are the types of multi-objective optimization. And then evolutionary algorithms or genetic algorithm is very why meta-heuristic algorithms are getting popular here in multi-objective. Why meta-heuristic algorithms are very popular? Why not classical algorithms? Can I give it that? Oh, okay. One more technical difference between single objective and multi-objective optimization. Can anyone tell in terms of local and global? I'm not saying according to the number of objectives. Can anybody tell the distinction between single objective and multi-objective with respect to global, local solutions? You see, in single objective optimization problem, we are looking for global optimal solution. But in multi-objective, we don't have global optimal solution. We have a set of solutions. And those set of solutions are non-dominated solutions or Pareto solutions. All are equally good. I told you one scenario given to you. So all are equally good. So you are not going to solve global optimal solution in multi-objective optimization. So your task is to, in multi-objective optimization problem, your task is to find out a set of solutions. And those set of solutions are equally good. And those set of solutions are known as Pareto solutions. And in addition to this, what you are looking for, like global and local. Here also you need to find out the true Pareto front. True Pareto front. And this is the really challenging task in multi-objective optimization problem. And since we are trying to uncover set of solutions, therefore people are excited about using evolutionary, I mean population-based stochastic search algorithms. Population-based stochastic search algorithms, all meta-heuristic algorithms. They are population-based. So set of solutions actually you can uncover. So therefore, they are getting very popular. So one of the this is pure genetic algorithm. Definitely we have to look at variety of techniques developed in population research to tackle multi-objective optimization problem. The complexity of their solution calls for alternative approaches. Complexity includes large thought spaces, noise, disjoint Pareto curves. This is disjoint. If the function is disjoint, you cannot apply your derivative method. No, differentiation will not work. So therefore, your differentiation method will, your conventional method will fail, and also uncertainty. So since the complexity includes all this, therefore the meta-heuristic algorithms are very important. And population-based method of ES can tackle large space and large disjoint Pareto curves, etc. So therefore, it is getting popular in multi-objective optimization problem. So objectives in multi-objective optimization problem. What are the objectives? The objectives can be listed as to find a set of solutions as close as possible to the Pareto optimal front. That is, when you are true Pareto front, we are looking for 2.1. To find a set of solutions as diverse as possible, diversity must be maintained. They should not be close to each other. Diversity must be maintained. As MOES, multi-objective equation algorithm, they should two spaces, a distant variable space, objective space. Diversity can be defined in both these spaces. Diversity in one space usually means diversity in other space. This may not be so in all problems. This task is to find a set of solutions where good diversity in the desired space. So this is one of the scenario I have taken from my paper. So this is your decision space, this is your objective space. So functions are there, then this is the decision variables. We have a strong mapping. In one space, diversity is maintained, definitely, not definitely, but sometimes you can maintain the same diversity in the objective space. Now, the real definition of dominance. So, domination, after getting this definition, then you have a chance to find out the set of non-dominant solutions from the set of given set of solutions. A solution X1 dominate the other solution X2 if both conditions 1 and 2 are true. This is the symbol I have taken for my convenience. The solution X1 is, the first one is, these are the two conditions you need to ensure. What are those two conditions? The first one is, the solution X1 is no worse than X2 in with respect to all objectives. This is the first condition. Are you getting me? The solution X1 is no worse than X2 in all objectives. Okay? And better than all objectives. Then the second one is the solution X1 is strictly better than X2 in at least one object. Strictly better than in at least one object. Okay, so these are the conditions you need to ensure by finding out the dominant solution, non-dominant solution from the given set of solutions. Okay, with these conditions, now can you please find out the non-dominant solutions? Now it is your turn because you are getting sounds different for you. So please go through this. So UES in 1990. So this is also one of the popular algorithms. MOCA. NSJ, I told you, no, someone has asked me which one is better. Good. So NSJ, of course, it has different versions. Not dominated something genetic algorithm. This is introduced by India Srinix College of Engineering. He is one of the veterans in the field of multi-input optimization. Two veterans, two pioneers. College there, as well as Carlos ACOLO. That I will cover. So that also I will show you. And LPGA, EPA, so many over the years, so many different algorithms, optimization algorithms have been developed under the umbrella of Python approach. Okay, these are all Python approach. So these are the applications, possible applications, like for example, MOE in data mining, real-time task scheduling, groundwater contamination. Also, groundwater in the environmental science people, they are also using soil algorithm, groundwater contamination, land use management, intrusion detection, and some combinatorial level problems like native level routing problems, knapsack problem, close of scheduling problem, and so on. And aerospace engineering, mechanical engineering, nuclear. So almost all engineering problems we are using this particular problems. So if you want more about this, then please visit this Investor Mexico. This is maintained by Professor Carlos ACOLO. He is the one of the pioneers in multi-objective optimization. So this is this site maybe you can visit. So okay. Then next we will jump to multi-objective machine learning. So multi-objective machine learning. So these are the ones we have already completed. So I am just highlighting. So you will see two theses I have guided. This is one particle swarm optimization for multi-objective problems. So we have used particle swarm optimization for multi-objective optimization problems. In the year 2010, one of my PhD scholars has got the award with the title particle swarm optimization PSO. PSO is very popular during that time for single objective optimization, but we have extended the idea to multi-objective optimization. Then what are the difficulty we faced during that time? You know, in PSO, there are also two things are really guiding the something something bad. That the G-based arguments and best, local best, global best. Okay, but in multi-objective, as you know, in multi-objective optimization, we don't have global best. No, we have a set of optimal solutions. Therefore, in order to do that, we have maintained an archive. Okay. Based on that archive, we have successfully conducted this experiment. Then another student got an award like from my university, this is from KIT University, this is from my university. Parallel single and multi-objective genetic algorithms. Here the spectrum get to parallel single and multi-objective genetic algorithms. So during that time, actually 2011, we don't have that infrastructure in our university. So we have what we have. We have a very cluster computing environment, cluster of workstations. So 3 workstations we have combined and then one on the experiment. And also, and this one is also one of my PhD students here, Harihan Kalyan, but he is no more now. But he has done a very nice one, multi-objective fuzzy genetic role binding. So fuzzy set we have combined with multi-objective genetic algorithm or multi-objective optimization. For rule binding, I need to report what is that rule binding? Classification rule binding. How it is discussed? In the past, we have discussed classification rule binding. And another part, multi-criteria decision making using machine learning techniques. So multi-criteria decision making is again a different kind of story. Okay. So MCDM means you have a set of solutions from set of Pareto solutions. How to choose a single solution from this set of solutions. So that is known as multi-criteria decision making. So many algorithms have been developed, like for example, TOPSIS method, AGP method, so many methods have been developed. And couple of this is a very interesting part. So let me highlight it for you. Actually, every alternate year I am conducting an international conference. That conference is biologically inspired techniques for multi-criteria decision making. So you can search in the web. So I am conducting this. Actually, this is the brainchild of Satyanarayana with myself. Okay, and in the year 2020, we have successfully conducted that conference. So you will get multi-objective optimization of problem, multi-objective optimization. Many activities belongs to that category. And also in 2022, we have the second version. The third version recently we have concluded in Nagaland University. So maybe in 2026, I will again conduct this one. So this is all published by Springer. So you see different series. The first series is learning and analytics in intelligent system, and this is your smart innovation systems and technologies. These are Scopus, all are Scopus, and also learning and analytics in intelligent system, the previous one. And a couple of papers, these are my article published. No, not papers. These are books, edited books, not proceedings, edited books. Okay, not textbook also, edited books. And in 2008, we have edited this multi-objective evolutionary algorithm for knowledge discovery in databases. During that time, it was very hot. And then fast book. So you can also go through this book. You will get lots of idea about multi-objective evolutionary algorithm. And Balasore and myself and Professor Post, we have edited one more book, that is Swarm Intelligence for Multi-Objective Problems in Data Mining in the year 2009. And also we have edited another book. Your Mrutyunjaya Panano, he was one of the speakers, but unfortunately he could not know. Anyway, so we have edited this one, computational intelligence series. And these are my few publications related to this multi-objective, related to only multi-objective. So this is one of the good articles. Multi-objective artificial deep learning algorithm. Like honeybee, you know, honeybee. Based on the it is the kind of measure inspired algorithm, honeybee algorithm. In redundancy annotation problem. So how do you develop a system so that you can maximize the reliability and minimize the weight and minimize the cost. So this is a kind of multi-objective optimization problem. So And then surrogate assisted multi-objective genetic algorithms for rule based classification. This is good journal. This is SCIE, SCIE Science Application Index expired. Okay. So you need to, until and unless you publish this kind of journals, you want to get a project from government of India, government for an assignment, or maybe university, you want to get a job. So you need to publish good quality papers so that you can get job. Similarly, so this is surrogate assistant, very interesting concept. Surrogate assistant. So this is another one. This is a top scientific article. Multi-criterion bioinformation particles are multiplied to polynomial neural network for classification. So this is a new article of course, and computer science review. This is one of the good journal of Elsevier science. So for that also I got 500 euro during that time, 2009. And this is another interesting one. Application of entities to multi-objective genetic algorithm for classification of generation, appearance of computing journal. And this is one of the knowledge based systems, also a good journal. So these are all good journals. So you can publish your paper. I think shall we continue more? We will stop. So let us stop. Otherwise, I have a couple of slides for MCDM. So these are the method, weighted score method, TOPSIS. So these are the methods for selecting a best solution out of set of solutions. Okay. And these are the methods. Let me quickly, finally, let's conclude this with a last slide. So this is the last slide of a set of other methods. And this is my books. You can book my prosthetics, you can follow and you can buy it and get more and more royalties. So I think make myself very rich. So this is the kind of cross-selling. I'm not only selling my products. So these are the couple of books and prosthetics. So thank you for listening to me.
Sir.